Yeah, good morning, sir.
शैलेश कुमार को एक्सेप्ट करो रूम में क्लोज करो
Now, say. It was muted.
प्रोफेसर कुमारेसन अभी चालू करो
Hello, sir. Are we audible?
Hello,
Yeah, yes, sir. Good morning, sir.
good morning.
will take some 15 minutes.
Yeah. We'll start in next 15 to 20 minutes.
Good morning, sir. Congratulations, sir. Can you hear me?
Good morning. I can hear you.
Yeah, so good to see you. Good morning, Dr. Kumar. Good morning, Professor Shailesh. Can you hear me?
Yeah, we can hear you.
Okay.
Yeah, I'm sure. Okay. Yeah, go
Yeah,
ahead.
so we have some 9 minutes. We will start. Already we have Professor Anirban, Dr. Pranav, and Dr. Mayank are already here.
Baba is also there.
Good morning, Professor Bhava.
Good morning. Good morning.
How are you?
Yeah, fine, fine.
He's also.
Somebody sit and then admit people.
ये किधर लेना पड़ेगा है एक दो है यहाँ ये भी है
ये पीटी के लिए
Good morning, everyone. A very warm welcome to day 2 of the National Conference on Computational Geometry Analysis and Machine Learning, jointly organized by the Department of Mathematics, ICT and S.I.W.S. College. It is an honor to host you all today. Yesterday, we witnessed a wide range of compelling invited talks, each exploring the intricate connections between geometry analysis and machine learning. From theoretical insights to applied innovations, the discussions were thought-provoking and intellectual stimulating. The sessions were marked by active engagement, insightful questions, and valuable academic exchange. We extend our gratitude to all the speakers, chairs, and participants for their enthusiastic contributions and presence throughout the day. Now, it is time to move on to one of the most awaited segment of the conference, the panel discussion on artificial intelligence and mathematics education. As AI reshapes both industry and education, mathematics must evolve to remain not only relevant but central in this challenging landscape. Today's discussion will explore how mathematics education can be reimagined through interdisciplinary approaches, blending mathematics with computer science, biology, engineering, and the social sciences to meet the challenges of the future. We are now privileged to have with us a stellar line of experts, each of whom brings a unique, valuable perspective to this important conversation. I request the acknowledged panelists to please come on the dais. First up, we have Dr. Anirban Chakraborti, professor at JNU. Next, we have Professor S. Kumaresan, sir, founder of the MTTS program, who have joined us virtually. Next, Dr. Pranav, Senior Engineer Education Team at MathWorks. Next up, we have Dr. Mayank, Senior Scientist at TCS Research. Dr. Shailesh Kumar, Chief Data Scientist at Reliance Jio, who has joined us virtually. Next up, we have Dr. Ravat, University of Illinois at UC Berkeley, who has joined us virtually. Moderating this session is Dr. Kumar, Professor and Head of the Department of Mathematics at ICT Mumbai, a renowned educator and visionary in mathematical pedagogy. Without further ado, I now invite Dr. Kumar to take over as the moderator of this panel discussion. We look forward to an insightful and stimulating exchange of ideas. Thank you.
Thank you, Gopal, and very good morning to all of you. And I welcome you to this second day of this conference, and something which actually I am very excited about, this panel discussion on artificial intelligence and mathematics education. As Gopal mentioned, we have distinguished panelists and we have several agendas. So just to maybe I'll take few minutes to kind of set the tone. So as you know, in this era of technology, it is actually reshaping all walks of life, and the intersection of artificial intelligence, mathematics education presents unprecedented opportunity and challenges. So this panel discussion is actually part of this conference, aims to explore how AI is transforming the way mathematics is taught, learned, and practiced in academic and also in real world context. Of course, there are a lot of AI-driven tools that have opened new avenues for personalized learning, intelligent tutoring system, automated problem solving, enhanced data-driven teaching strategy. But we also believe that fundamental principles of mathematics remain central to the design and functioning and advancement of AI algorithms. Thus, the dialogue is very crucial, not only to understand the influence of AI on mathematics education, but also to appreciate how mathematics continues to be backbone of all these tools that we have today, namely machine learning, AI, and all that. We are very privileged to have distinguished panel of experts, each with vast experience and notable contribution in the field of mathematics education and AI. Their insights will help us reflect upon current trends, identify key opportunities, and outline a roadmap for equipping next generation mathematics students to thrive in technology intensive world. So one of the aim as mentioned is to kind of look at what are the opportunities that the AI provides for we the mathematics students. At the same time, what are the challenges that we have? Maybe we can through this discussion create some kind of roadmap or guidelines, maybe policy.
Your audio is not coming.
To let me
Is there some audio problem?
Yeah,
Yes, sir. Yes, sir.
continue.
Hello, Ajit. There is some audio problem.
Maybe he himself is unable to hear.
Yeah.
Unmute. He unmuted himself.
we'll just share those 6 questions.
Share.
In the meantime, let me read it out. Of course, these 6 questions serves only as a framework for the discussion, but the panelists are free to raise any additional points which they feel relevant, and based on the questions from the audience, we can look at them as well. So let me very briefly introduce the panelists. So the first point that we are going to look at is what opportunities does AI offers to mathematics students. The second one is how can mathematics education be aligned with evolving needs of AI industry, and what are the essential skills should students acquire? The third one is how can AI be incorporated in curriculum while preserving the rigor of core mathematical concepts, fostering computational thinking. And the next one is what pedagogical strategies that are best suited to address interdisciplinary challenges posed by AI. You know, this AI has also opened up new avenue for interdisciplinary collaboration. So this is one such. And what are the national policy interventions that are required to support effective integration in integration of AI in mathematics education? But although we are actually discussing AI in mathematics, but you can replace mathematics with any other subject, it will equally be true. So the first panelist we have Dr. Shailesh Kumar. He is the Chief Data Scientist at Center for Excellence in Artificial Intelligence Machine Learning at Reliance Jio. He has held key roles in Ola Cabs, Google, with expertise spanning in AI, machine learning, computer vision, natural language processing, and there are several others with applications in finance, retail, and education. He is also co-founder and former chief scientist of Third Leap, an education tech startup that focuses on AI-driven personalized learning. So thank you, sir, for joining. We are really grateful to you.
Thank you for
I must mention this was suggested by our honorable vice chancellor, who is in the audience. And we are really lucky to have you, sir, and your experience.
Thank you.
Next, we have Dr. Anirban Chakraborti. He is a professor at School of Computational and Integrative Science, JNU Delhi. With over 2 decades of experience, he had held key academics and administrative roles in India and abroad. His research spans in various domains like equal physics, social physics, complex systems, and data science. Yesterday, we witnessed a glimpse of his work that he does with so many things. He has been awarded Young Scientist Medal and also was UNESCO Fellow in 2023. Next, we have Dr. Mayank Baranwal, a senior scientist at TCS Research, Mumbai, and adjunct faculty at System and Control Group in IIT Bombay. He holds MS and PhD degree in mechanical engineering from USA, and he also, by the way, holds MS degree in mathematics. So he has dual MS degree, one in mechanical engineering and one in mathematics. So welcome, Dr. Mayank. He has a lot of experience. Of course, he also has received multiple awards, including NASCOM AI Research Award in 2024 and Young Scientist Award. Then next we have Pranav, Dr. Pranav Lal. He is a senior engineer at education team in MathWorks, Pune. He collaborates. MathWorks is the one which produces this math lab. All of you may know. So he collaborates with academic institutions to enhance research and learning outcomes. His expertise includes mathematical modeling, data analysis, AI, robotics, and many other things. He is PhD and Masters in Mechanical Engineering from IIT Bombay. Next, we have next we have Dr. Kumar Ravat, a faculty at the Department of Applied Probability and Statistics, the University of California, Santa Barbara. She has done PhD from UC again. She has prior industry experience at Eve Star Trade, and she also has led an initiative called KIO Global Leadership Exchange Program with Japan and Data Science Pathways. So we have very distinguished panelists. Last but not the least, and Professor S. Kumaresan. I don't think he needs any introduction to at least mathematics gathering. Just to begin this discussion, I would like to invite him to share his opening remarks and possibly set the tone, because it's already 10 o'clock, I think, in the US. So I don't know how long he will stay in the discussion, but I'm sure as long as he's there, he will spend. So Professor Kumaresan is legendary figure in field of mathematics education in India, known for his inspiring teaching and deep commitment to nurturing young talents. He has dedicated his life to improving mathematics education at grassroots level, and for last 3 decades, he has led a renowned mathematics training and talent search program, popularly known as MTTS program, an initiative that has transformed landscape of mathematics learning and mathematical skill development in the country. Just to say, look at the success of MTTS program is quite evident with the fact that at any mathematics gathering, one can find a group of individuals having lineage to MTTS program, and I'm sure there are several in this audience, including myself, and there are few who have joined online. That's what I saw. So, Professor Kumaresan has also been strong proponent of integrating mathematical software into teaching and learning. I personally actually owed my early exposure to such tools in late 90s to him. In fact, if you search on Google, some individuals who in India who is known for promoting mathematical software, probably you find my name there, but the true credit goes to Professor Kumaresan. So first of all, just to mention, we have also invited several HOD from Mumbai University colleges because this topic concerns all of us. So and several of them have joined. Few of them have come personally. So I thank you all of them. So let us begin the discussion. I invite Professor Kumaresan to share his thoughts. Thank you, sir. Please go ahead. We are not able to hear. Just speaking.
I'm ready.
Sir, please go ahead.
Yeah. Thank you very much. It's really wonderful to be here, and something that theme of the panel discussion is somewhat very close to my heart because last few years I have been thinking about it. Okay. And the first thing is, one has to accept the truth that any new technology is very disruptive. Okay. So the human race has to find ways to kind of survive. Okay. Any kind of technological innovation and thrive on it. So that way, I think it's wonderful that we have to do. And there are two things which are very close to my heart. Essentially, mass education, how AI is going to affect. Okay. And second thing is, which is somewhat very close to my heart, that employability of our students in the country, not only for math students, I talk about all students. Because as all of you know, AI is going to take over a lot of jobs. But that was the case when the computers also came, people thought about. So we have to kind of innovate ourselves, prepare our skills to face that kind of problem. Okay, this is something I kind of foretold more than 2 decades ago in my classrooms all the time. I'm not even sure the word AI was not known to me at that time. Okay, and perhaps fathers of AI thought about it. I said to them, and soon the day will come, you don't have to write any program, you just say and ask the computer. When I said computer, it's within quotes. Okay, so give your code in a language of a choice. Okay, as you know, it's happening. So naturally, one has to change. So I will just take about only brief things. Okay, the first thing is, see, I always held, even before these computers came, there are two kinds of students in any science, in particular mathematics. One who is more theory oriented. There is other person who is somewhat very application oriented. He just has a smattering of theory that's good enough for him to forge into solving real world problems. So both are needed for the human race to progress. So neither should look down upon the other. Okay. If that be the case here also, I think the math is going, it's a kind of two-way process between AI and mathematics. Okay. Math is going to give the tools, power to AI, and AI is going to be disruptive in AI in mathematics because of various other reasons, like even in teaching, the way you are going to evaluate a person, and not only that, even try to prove theorems, perhaps. Okay. So these are the things which it's a two-way process. We have to be ready for any one of them, whichever role wants its in. Okay. So what are the things I would like to really kind of think about, or all of us to think about, is that how do we prepare our students? I'm still worried about all students. Even though math is close to my heart, I think of all students. Okay, how are we going to prepare? Because as you know, all industry always keeps someone saying about unemployability of students from even some technical institutes, etc. So if that be the case, AI is how are we going to manage? So I think first thing in my opinion is there should be a radical change of the way one teaches. Okay. The teachers should, okay. The next thing is the teaching is not bad in the sense that, many people will be ready to do if you tell them to change the teaching in a better way. But what prevents is the real thing is the so-called assessment. Assessment simply means written examination in India, right? So even the best students do not want to learn the subject, but they want to crack the exam. They want to be whatever the top grade or what is called CGPA or whatever it is. Okay. So if you want to change not only the curriculum and the teaching method and the assessment, all these three have to be given a fresh thought. If you don't do any one of them, for example, if you simply say, okay, AI, so put all these things, like, when computer came, all of a sudden CBSE introduced C, then it C++ became the kind of fashion, object-oriented programming, they put C++, now perhaps Python, I do not know. Okay, so that's not the way to go about. Okay, the better thing is you have to have a kind of idea what exactly you want to do. You want to equip them to do two things. One is what I call critical thinking, pure mathematical thinking.
Professor, we are not able to hear you. Can you just pause for a few seconds? We are looking at
Is there a problem? Let me just see. I kept it in the maximum, I thought.
No. For us, it's not a problem, sir. We are able to listen.
Oh, it's can you just do
No,
something at your end?
we can hear to you, sir. No problem. I think there will be a problem with some machine.
Yeah, I kept it in the last thing, the highest level. If you want, I can try to raise voice. Okay. Right. It's the end of the day. It's a little tired. Okay. I'll do that. So as I said, curriculum changes should not be just like that kind of knee-jerk reaction. Okay. For example, there are all experts, they will immediately will say these are the things we need, mathematicians should teach. So you just try to do all those things. Okay. And that's where I also differ. And second thing is the way the first thing is curriculum, the second thing is teaching. The teaching has to be completely different. You have to engage the students. And what happens typically in all theory-oriented courses, you teach a lot of theory. You don't give enough time for them. I'll give a very simple example. About 15 years ago, I conceived of a course in data science and machine learning in the University of Hyderabad. And to the best of my knowledge, none of the institutes in the country, including, I don't want to say, they have not done that course at the time. Okay. I have no idea about machine learning. I went through the things and I found about 10 most important algorithms. And based on our students' thing, the expert who was supposed to teach and I sat together, we chose those 6. Okay. So we didn't want to teach everything. We wanted to teach something very complete basic and also the most important one, and then hope we have trained our students well enough so that they can forge ahead on their own. This is one of the things I find throughout which in our institutes across the country and across the discipline, people try to teach too much. They don't believe unless I teach you, my student may not learn. That's not the way. Students are more intelligent, they will learn. So the best way is you show them the correct method and teach them and leave it to them to find out their expertise on the job. On the job meaning not exactly job, whatever it is. Okay, that's one thing. And second thing I want to talk about is, for example, suppose I want to do AI, and I was talking to Professor Shailesh, and we were also saying the same thing. See, there are 3 disciplines. Mathematics is involved, theoretical computer science involved, and artificial intelligence under various names perhaps. Okay, it's all encompassing in some sense. You can talk about data science, machine learning, NLP, LLM, artificial intelligence, put everything. Okay. And I think there should be some kind of a course should be taught by 3 people together. Somebody from maths and stats, okay. And second thing is the computer science. The third is from AI, who is actually working such thing. And there should be some kind of very regular collaboration and exchange of thoughts so that they should know how they are doing. For example, in MTTS, we had been doing it for the last 34 years. Okay, all the teachers how to sit. I cannot say that I teach analysis and I will go away. I don't care what algebra or number theory or topology or whatever the guy is doing. Okay, we have to be there. We learn and we also use it in our course. So the same way you will know, because this is one of the things with pure mathematicians we do. For example, I've been doing it very long ago, not last 4 decades. Okay. And I love mathematics. I do mathematics. I don't care what are the applications. Okay. But students, many of the students, about 80% of the students are worried about applications. Okay. That's what. Remember, as a teacher, I know it's a escape route for them. Okay, they don't want to learn something tough, so they try to deflect the issue. What are the applications of real analysis? What are the applications? So we are aware of that. Okay. So I think that at least one course should be taught in tandem by 3 experts in 3 different disciplines. Okay, that's the kind of thing which will see the students will understand the need for all the 3. Okay, and coming to the thing, we have to abandon like this written exam thing. I would simply say, see, now the world is so difficult, especially these things, and not a single person will be able to solve everything. Okay, and even if you can solve, because there is a time constraint. Okay, your boss or there may be kind of thing, you have to do it within time period. Okay, if you give me a year, I may be able to solve, but the product should be ready, let's say, within about 3 weeks or 4 weeks or something. So that means there is a need for a teamwork. So that should be trained among our students from the beginning. So I would say, instead of saying you solve this problem alone, I would say give us some kind of a group study and ask them to discuss among themselves and do that. And only the group will be evaluated, no individual. Because when you work in a team, if there is a team working uh, uh, in industry, okay, either the team survives or the team is dissolved. Only the team leader may be shifted to some other team. Okay, so one has to understand the teamwork should be kind of inculcated. Okay, there is one more thing I will just talk about. I don't want to take much time because it's about 90 minutes only. Okay. So one of the things which I thought about is that this assign you should simply ignore, and as they do some kind of case studies in MBA, etc., you give some kind of thing which uses all these concepts, maths, computer science, and AI, and ask them to work on something. And there in a class of 40, there could be something like about 8 different case studies. Do that. Okay. And ask them to exchange. And only the groups will be evaluated, and the groups are evaluated only essentially only on 3 categories, no grade, in the sense it is below par or satisfactory or good. Okay, so there is no specific grade for any individual. Okay, so that will be the one of the things which will kind of allow them to work as a team. Okay, this we have seen it works in MTTS. Okay, we have a group discussion where the good student tries to improve the performance of the others also. So everybody comes up. Okay, and because again in a typical team which works in industry, you will see there will be kind of people. It's like a queen bee who will be a team leader, okay, who essentially knows the overall picture, okay, and administration, how who is good for this job, delegates the correct thing and get the job done. And there will be kind of worker bees, they have to do all the kind of coding, programming, etc. There will be a third thing which will be essentially theory oriented. If something is not working, he will use his mathematics or theoretical computer science or whatever and try to give. So this kind of thing also our group study or teamwork or casework, okay, or group assignment will foster. These are some of my thoughts, but there are a lot more. But as we go along, we can discuss. Thank you very much.
Thank you, sir. Now
Was it reasonably audible?
yeah, in between because of some technical difficulty, we had lost you for
Okay.
few seconds, but
Right.
it's fine. I think
Okay. Thank you.
I hope
There was
that
no
you could
problem, sir.
proceed for the
Okay. Thank you.
session. Yeah. So now let's move on to the first item or first question that we thought of. What opportunity does AI offer to mathematics students? So I would like to call upon first Dr. Shailesh to share his thoughts on this agenda point. Dr. Shailesh, please.
Yeah, thank you. Good morning, everyone. Thank you, sir, for inviting me. And thank you, Kumaresan, sir, for opening it with such a nice overview. So let me first a little bit, second what sir was saying. And one of the themes that we have been working on is we are treating mathematics, computer science, and AI as three different subjects. But if we think about it, they are highly connected to each other. And if I look at, mathematics, algebra is equal to algorithm, right? If you think about what does algebra do, it's really the foundation of the modern algorithms in computer science. And when we implement things in computer science, we help mathematics also back. And obviously we help computer science also, AI also. And, AI is also built on the foundations of mathematics only, right? Like, statistics, probabilities, linear algebra, calculus, and all of that. And obviously now AI is also helping back in the mathematics world. So I think the first, big message that I think we should take out of it, this is like Professor was saying, are mathematics, computer science, and AI three different subjects, or are they highly interdisciplinary and connected to each other? And we have created silos by teaching them as three different subjects. So I'll give one example. When I was teaching algebra to my daughter in 7th grade, I realized that when I'm introducing algebra in the mathematics world, I can introduce the idea of variables in programming. And, there is a very nice parallel between them. Now, if you're not teaching these two topics in the two classes simultaneously, there's a disconnect. So the point in education is that, I think we are adding too many nodes in our brain. We are not adding too many edges between the nodes in our brain. So I'm using a graph analogy here. Too many nodes are too many concepts. We are teaching them concepts as if they are independent concepts. Algebra is independent and programming is independent and AI is independent, but we are not building enough connections between those concepts. And that I think will reduce the number of nodes, but increase the number of connections. And that is what, new innovations will happen. Because it's all about connections between the nodes that we have created, right? And if people and kids can see the connection between, mathematical thinking, algorithmic thinking, AI thinking, and they can see that they're all the same, then, a new kind of aha moments will come for them and they'll have a next level understanding. So that is one theme that really I think we should harp on and create curriculums. The core curriculum should include all the three subjects in a very tightly coupled, synchronized manner without the boundaries and silos. Now, coming back to this question, I think there are two big opportunities that, AI offer in mathematics. One is on the learning side and one is on the research side. So if you think about learning side, in my startup, I built a tool which could do reasoning, mathematical reasoning, show all the possible solutions of a math problem, not just one solution, and let the students learn that there are multiple ways to possibly solve a math problem. There are good ways and long ways. There are ways where you need to know certain concepts. If you don't know them, you are going to take a different route. And ultimately, the learning in mathematics is not just about the concepts of mathematics, but also the power of reasoning and thinking about creating solutions through a long chain of sequence of applying those concepts. So how do we bring these two? And AI can really help. And the idea was that if a student is stuck on a particular step, AI could just open the three possibilities or five possibilities and let the student pick one to move to the next step in the problem. So how do we give hints? How do we understand the student that he is stuck on this step? This step requires these five concepts or one concept. Therefore, this concept is what the student is not getting. And it is the concept that matters, not the problem. And AI could figure out that, oh, I could now give him simpler problems on that concept. So on the learning side, there's a lot of things that AI can do. Give the right problems next and all of that. And we'll talk about it later as well. And on the research side, we have seen how, mathematics reasoning has come up as a very big area in AI. Obviously, the way they do it is probably not correct by giving a lot of examples and let AI algorithms learn. by pattern recognition, that is probably not the right way to learn, mathematical reasoning. But if we did it right, it could be a very handy tool all the way from, when we used calculators to MATLAB and visualization and graphs. And now AI could be just yet another tool added to our research. And obviously, it can help us make a lot more faster progress in research. So I think we should explore both what role AI can play in learning as well as in mathematical research. Yeah, thank you.
Thank you, Dr. Shailesh. I would like Dr. Pranav to also take this question and add to what Dr. Shailesh has said.
First of all, thank you for inviting me here to be a part of this mathematical. I come from industries, particularly MathWorks, which make the software with MATLAB. So I also try to be that perspective here. But we all agree that AI is basically built on the top of mathematics, right? So there is no confusion there. So because now we have AI coming up as a main theme and a main technology as well, it definitely provides a lot of opportunities for mathematics students within industry as well. Right. The first thing is we are developing AI which can solve some sort of problems. When we develop a particular model, it can solve a specific problem with certain amount of data which we have used to train that particular model. But there are a lot of ambiguities as well in the AI models as well right now. There are a lot of corner cases which we are not able to solve in the first place using the AI tools. So that's why there is still a lot of scope for development of AI algorithms using mathematical techniques that we have. And that's where the role of mathematicians is going to be very crucial in the first place. So that's the research aspect. Development of AI itself is where mathematicians will definitely play a huge role. On the other hand, when it comes to the applications of AI, particularly in industries, there are again multiple things. I can highlight maybe a couple of them. As I said, I come from MathWorks. We have mathematicians who are leading the development and product teams for AI within MathWorks, right? So when it comes to software development as well, nowadays what happens is when we're developing a software which is a regular software, non-AI based software, for example, typically we can make correlations between the lines of codes that we have written and the outcomes that we are going to get. There is a one-to-one mapping kind of input versus output. But when we're developing the AI software, for example, the software which has AI components in it, we'll probably not be able to get the one-to-one mapping in that sense, right? So when it comes to software testing, software verification and validation, the usual mathematical techniques will not probably work, or usual logical thinking probably will not work, and that is where we need researchers, or we need employees who are skilled in the skills like statistics, probability, and so on, which will help us to also test the AI algorithms, right? So that is the one way of looking at it. Like software development also provides a lot of opportunities for mathematics students in verification and validation of those softwares that they're building using AI technologies. On the other hand, when we're talking about core industries where they are using AI, okay, we have developed the software, we have developed AI algorithm. Now, core industries like mechanical, aerospace, electronics, a lot of them are using AI. In early days, it was quite fascinating to them, like seeing, okay, AI is providing us some results, we are quite happy. Nowadays, they are also trying to question the outcome that AI is providing to us, right? What is the reason behind the outcome that AI model is providing? So that is where explainable AI kind of thing is coming into picture. We have to think about why that particular AI model gave this particular outcome, or what are the factors that influence that AI model to give us this particular outcome, whether we should trust that AI model or not. And when we try to ask such questions, that is where I think the role of mathematicians come into picture, where they can help us understand how trustworthy is that AI model, how robust is that AI model, and so on. That's where all this, again, statistics, the algebra, probability, calculus, all those basic mathematical concepts really help. And towards the end, of course, since AI is in boom, we are seeing a lot of institutes across India who are starting very new departments with the institute which are teaching AI related concepts. And I'm really not very sure whether we really have faculties who can teach math for AI in those institutes. So the mathematicians that get training here, for example, they find good opportunities to actually go into these institutes where they're planning to teach AI, but we need to teach foundations of AI as well, and that's where I think mathematicians will find opportunities there.
Thank you, Dr. Pranav. I think, Professor, you have raised your hand. So
Yeah, I think many of us have problem with the audio quality. Maybe you can your mic seem to work much better. That's
Okay.
one of the suggestions from one of the audience.
Okay. So
Yeah,
possibly it is because of the distance of the laptop. So that may be the, maybe I shift
no.
your side.
For example, everybody online has complained about the audio quality. For example,
Yes,
with the
sir. Yes, sir. The audio quality is poor, sir.
so whereas with your mic it seemed to be all right, Ajit.
Am I audible?
Is it better now?
Is it better?
Yeah, no, test it with the last speaker.
Yeah, is it better now?
No,
Yeah,
sir.
it's slightly better.
And compared to earlier, it is little better, but
Yeah, still,
Yeah, it's a better now.
Put it in between.
yeah, but still we have to struggle. Little strain ourselves a bit.
Okay, so maybe we'll just here. So, yeah. Okay, so let us move to the second agenda. Unless any of the panelists wants to add to this point, if you have something more. Okay, okay. So let us move to the second agenda point. That is, how can mathematics education be aligned with evolving needs of AI industry and what essential skills students should acquire. So I would like to call upon Dr. Mayank first to respond to this. Please come here and then. Hello, am I audible?
yeah.
Go ahead, please. Yeah, thank you for having me here. So one of the things that I would like to start with is, first of all, math remains the same, the underlying math remains the same. So I don't think in terms of the tools that we end up teaching to students or otherwise we end up like learning ourselves, that need to change. I think it's a viewpoint that needs to change. And I think Professor Kumaresan and Shailesh is also here. So one of the classical examples is the modern day reinforcement learning, right? And much of the tools that are there for RL, in fact, the theory of it has been developed by Wellman in 60s. And later, this stochastic approximation techniques by Professor Borkar, Professor Shailesh, they work extensively in those areas, but it was never popularized to an extent where people would start looking at the data-driven or the practical aspects of it. So this joint set that I think Professor Kumaresan. Hello.
Yeah.
Yeah. So this joint set Professor Kumaresan and Shailesh also sort of pointed out where we have mathematicians who are purists from the point of view of developing theories, but they hardly care about the application aspect of it. And there are these folks who only care about the practical aspects. They don't care about what really happens and when a particular algorithm doesn't work, right? So when I was a grad student, I'll give you an example. So every member in our group was actually required to take a course on data analysis, regardless of the research they wanted to sort of pursue. And the idea was that real analysis, in some sense, gives you a pessimist view of the work that you're doing, right? So you have to be extremely careful of all the corner cases. scatter sets, scatter functions, everything that you need to take care of to make sure that your algorithm or your theory is foolproof, right? So that is the kind of thinking that is needed from the point of view of someone who is more sort of practical oriented. So in terms of the curriculum, and I also try to incorporate this in my courses, I usually start with the bigger picture. So if it's about, let's say, mathematics and AI is what we are sort of concerned about, I would actually start with one particular example in AI, and that would be my running example throughout the course. And then I would be looking at that example, try to maybe develop better and better algorithms to sort of tackle that particular case. So students can always sort of relate to that particular example, relate to the methods that didn't work as well. Let's say I teach a course on optimization, and it is about optimizing a particular loss function in a neural network. It's a non-convex example, but let's say I start with a simple L2 regularization, which makes it a little convex and so on. I would then start with simple gradient descent. We would see how the trajectory sort of evolve. And then we would teach something with the momentum, and you see the effect of momentum. You have add a different variant of momentum. Then you talk about different combinations, which let's say Adam algorithm drive and so on. But then once you try and relate this to the bigger picture, which is the final use case that students are really interested in, that makes the class engaging. And I think that's the kind of attitude that's needed in terms of developing the curriculum. So instead of teaching calculus and probability and statistics in isolation, we should probably try and sort of relate it to maybe some applications in AI, and it should be centered around those set of applications that we are really interested in. So as I said, like the underlying tools that we are going to be teaching, they remain the same. It's just the way we sort of incorporate that into our curriculum, it's going to have a bigger role in terms of redefining the orientation. Another example is like when I was an undergrad, we had this mechanical engineering lab. And because of the way the course was structured, we would have one lab course in one of the semesters, and under that particular lab course, we would have a lab component from fluid mechanics, another from controls, another from one more discipline, and so on. Now, from the point of view of student who hasn't done and taken a course on control, basic control, and if you ask them to, like, if you show them some demonstration of the IT control, they are hardly going to be able to relate to it. And I think that is what is happening in the curriculum, that way we have designed curriculum. We teach these concepts in isolation, and I think that Dr. Shailesh also mentioned this at some point. So we teach these concepts in isolation, we never give them the bigger picture, and I think that is what is needed, in my opinion, the most.
Thank you, Mayank. Maybe I would like to hear from Dr. Kumar on this point. Dr. Kumar, please go ahead.
Yes. Thank you for inviting me to this excellent panel and putting up excellent questions, which made me think quite a lot as well as to what needs to be done and what's being done well. As far as math education goes, I think like Professor Kumaresan and Dr. Shailesh already mentioned, we need to move away from procedural to conceptual teaching or thought process, so that we actually test that the students have understood things conceptually rather than just using math as a way to get the computation right, because AI is going to do the computation for you. So we don't need to focus on that anymore. We just need to teach students how to ask questions, what's the right question to ask, how to formulate a mathematical problem correctly. And then also I'm realizing that how do you interpret the result? Like, how do you communicate that result to the audience once you've solved the problem? That becomes important as well. So we shouldn't let go of our proofs in mathematics, because they really help you struggle with the ideas and communicate it in a nice, concise way, which is very important. And then I agree with everyone that, bringing in real world situations in a math classroom to model it and help students put the theory in a context is very relevant. And maybe I will share some of my personal experience. So I was trained in pure math, and I did end up taking a position in the industry, and I didn't have too much of computational experience at that time, but I think my math was so strong that industry was willing to put a bet on me simply because of my math training, where I could think abstractly, I could think critically and solve problems, and I think that was the skill that I brought to industry, and it served me well, and I guess it served the industry well too. It served E-Trade Financial well. But as a pure mathematician, I think what I struggled with when I went to industry was, in pure math, everything has a right answer. And even though you may have many ways to get to the right answer, the answer is just one thing is the right answer. Whereas when you go into computation, you need to be able to uh, be comfortable with an approximate answer, and ways to get approximate answers are also varied, but uh, that just getting comfortable with that, if you have an approximate answer, it's also an answer, was something that my pure mathematical brain did not really get comfortable with for a very long time. So I would say that is one thing. And then I think mathematicians, you bring in a lot of skills that are very relevant to the workplace, but somehow some skills that are relevant to industry that, in the mathematics training that I had, I didn't really acquire those skills. But I think Professor Kumaresan touched on everything about that. I just emphasize it. Working in a team is very critical. So make sure you have projects and team projects to work on, so that you have the skills of working together in a team, having conflicts with your team members, and yet resolving that conflicts in order to solve the problem you're solving. So I think teamwork is important. Then I mentioned interpreting your results when you solve a problem, and then communicating it to a audience, and that audience might be your team in your individual weekly meeting. It might be a communication to upper management, but kind of communicating your understanding in layman terms becomes very important when you go into industry, and I guess in the AI field, it will become even more important. So I would say those two skills are something that if mathematics students learn, it'll just add to their value in the industry. Okay. Yeah. Thanks, Ajit.
Thank you, Dr. Kumar. Pranav, would you like to add something to this?
Maybe a couple of points just quickly. I agree with Dr. Mayank as well as Kumar on the things that they mentioned about the computational thinking. How do we incorporate computational thinking within mathematics education is very important. I also think that right now, especially when I come from applied, I come from engineering, so I see a lot of engineering institutes who are developing new departments totally based on AI. I'm not sure. I'm not very sure whether that's the right way to do that because AI should be treated not as a vertical in the education system, but it should be treated as a horizontal in the education system, just like we do in industries. We have some products which we develop horizontally, and then there are some products which we develop vertically. AI should be taught in the horizontal level itself. And that's where I think we can very well integrate AI with mathematics, because mathematics is also the horizontal subject that then aligns with a lot of other applied applications, right? So how can we integrate AI while teaching statistics, probability, calculus, linear algebra? I think that is very important. That's where I agree with Dr. Mayank when he said that when we show them the real world problem and then derive these independent problems from that, like there is I'm developing autonomous vehicle and then I am doing some computer vision applications to that. From that, we derive the image processing stuff, and then we end up with linear algebra, and then we should teach linear algebra concepts and so on. And similarly for statistics probability, I think that is a way to probably integrate AI with mathematics as well.
Thank you. So the next,
Sure. Please. Yes, sir. I'm sorry. Yes, so I'll give one more example, and I'm pretty sure that everyone here has heard of Shannon, right? Shannon entropy layer. So he started the theory of mathematical communication in 48 in his 48 paper and ended it in his 57 paper. And he did this while he was part of the industry. He was at AT&T Bell Labs, right? So it's the critical thinking, the computational thinking that basically, or the rigor of mathematical education is what's needed in coming up with something which is really abstract. In fact, he introduced this concept of entropy, which eventually helped E.T. Reeds develop his maximum entropy principle in the context of physics. So I think that level of thinking is naturally sort of incorporated in like mathematical training. I think if you take this thinking into industry, I'm pretty sure that you would be able to leverage a lot more than what maybe someone who hasn't had this formal form of like training would end up doing. So that's something that should be kept in mind as well.
thank you. So let us, would you like to add something to it? Or? Okay, sure. So let's move to the next question, that is the third one. How can AI be incorporated in curriculum? Some aspect we already touched about this, but incorporating AI into curriculum while preserving the rigor of core mathematical concepts and fostering computational thinking. So I would like to call upon again Dr. Shailesh, because he has worked on this. He has also developed some AI tool. So maybe share his thoughts on computational thinking.
Yes.
Dr. Shailesh?
Yeah. Can you hear me well?
Yes.
Yeah. Okay. So thank you, sir, for that question. So, the way I think about it, there are different words that we can use. One word is how do we change, how do we disrupt, and how do we reimagine. So I like the word reimagine, and I want to open this up to the education community in general. How would you reimagine education in the post-AI world? The question is not how will you improve education from the old 200 way of education to the next delta improvement, but the question is what would education look like if it was born after AI? And that's a very fundamental way of thinking about it. And when I think about it, one of the fundamental laws of education, if you will, is mastery learning, right? We cannot move a student to the next concept unless he has mastered the previous concept, right? Now, in our education system today, we have a one-size-fits-all curriculum-based education system, right? By this time, this much has to be finished. Course khatam karna hai, mindset, right? And what has happened is we pass everybody who has got 40% to the next grade and the next grade and the next grade. And by the time we are in the 12th grade, our students have passed all the grades with 40 to 50% marks. And look at where we are, right? Imagine if we were building buildings in that way, right? We finish a building, one floor, 40%, and we move on to the next floor. And therefore, one of the crises in modern education, especially in the Indian context, is this one-size-fits-all, education system. And what really bothers me is that we can today, with AI, personalize your Netflix, your LinkedIn, your Instagram, your pizza delivery, but we have not yet personalized your education, which is the most important unique journey of every child through the education system. So if I think of education as a journey where graphs, where nodes are the states of learning, right? What concepts I know, what I don't know, what I'm struggling with, what I forgot. So think of the GPS of a student, and every student is in a certain state of learning. And now we can ask three questions. What are you ready to learn next? Versus what your friend is ready to learn next are two different things, right? So this is what I call curriculum personalization. So AI can now understand the state of learning of a student and personalize the curriculum and say, hey, you have figured out LCM. Now you are ready to learn, adding fractions with the different denominators, because that dependence graph is something we educators can create. So curriculum personalization and mastery learning is the first use case of AI in education. The second is content personalization. So content personalization, like we all agree, different students learn the same thing differently, right? Some are abstract thinkers, some need real world examples first, some need something else, right? So the idea is which content is going to work for which student is still not clear. So if you go to Byju's and Khan Academy, there is only one content for a concept, and everybody has to learn from the same content. But in the post-AI world, imagine I am a student, my Gen AI system knows what concepts I know, what concepts I don't know, and then I ask AI to generate a content for me on the fly, which is going to respect this idea that this I know, this I don't know. And then AI can generate a very unique content for you. This is a very important reimagination exercise we have to think about, right? We have come a long way from printed static textbooks that everybody has to use versus highly personalized dynamic content, which is highly tuned to the level of students' understanding. And that's what a great teacher does when he teaches one-on-one. The teacher comes down to the student's level, understands the student's level, comes down to the student's level, and then take them up. This is exactly what AI can do for every student on the planet is now a possibility. So we have to reimagine education in that way. Third is the homework or practice personalization. Again, today, every student gets the same homework. And you can imagine, right? The smart kids do it very quickly and are bored to death of our education system. The kids who are behind have no idea what this homework is about. And only 20% of the students in the middle are actually benefiting from our education system. If you measure the efficiency of education today, that's where we are. And you all can look at your bell curves and see this. So the third is practice personalization. Again, there is no static homework given to every kid for a concept. Every kid gets a different homework. Kids who are behind get a simpler problem. If they solve it, they get to a harder problem slowly. And if they are not able to solve it, they'll go back to simpler problem and all that. So the idea of practice is always, again, very dynamic. Now, all the three things, what should I teach you? Which content should I use to teach you? And what should you be practicing next are highly personalizable. Now, the only problem is a human tutor who knows the student well can do this, but he's not scalable. So the question is, can AI become a proxy for a personal tutor and be a personal tutor for every child, right? And the fourth is assessment. For me, assessment is not about the grades, but really it's about calibration. I just want to know the GPS of the student. Therefore, I'm doing an assessment. I want to know if he has figured out minus of a minus is a plus. I just want to know that, not that he got a 60% mark or a 40% mark. So the purpose of assessment, during the learning process should only be calibration, and that should feed back into the state of learning of the student. And again, the three personalization. So the big promise that AI has is to bring personalization at scale to every student, because if we cannot personalize education, all of AI is a waste for me. We can personalize ads to consume more, we can personalize content to watch more on Netflix, but we are not able to personalize education. Is a big problem that as an education community, we should really think about. And we'll think about only when we all ourselves learn the capabilities of AI on how to build profiles, how to use them to optimize the learning paths, and really think about education as a very important use case, probably the most important use case of AI, and not the other things. Yeah, thank you.
Thank you, Dr. Shailesh. I think a lot of things that we, the teacher, have to learn if you want to make this effective in our teaching. That is what we are making, but I think there is no way out. We need to learn some of these things. Maybe Professor Anirban, you want to add to this something? Okay, sure. So Mayank, do you want to add? Okay. Any one of you want to supplement to what Dr. Shailesh has said? Professor Kumaresan?
Yeah, I would like to say something.
Yeah, please go ahead.
I really liked whatever Shailesh said. As Many of us who are interested in MTTS will know that we had been doing it at a human level, what is prescribing at AI level, and it can be scalable, which is a very good thing. The only thing is, how are you going to implement? It's not very clear to me, especially for 140 crore people. Okay, not 140 crore, of course, it will be 20 crore or something. But so those are the things one has to think about. But otherwise, I think all the points are excellent. And he more or less gave a kind of very good roadmap how to use AI to improve education. It has nothing to do with mathematics, by the way, because many of us, just because you have a mathematical background, we try to emphasize only mathematics part, but I think I would like to put it in the very larger canvas. It should be entire education. One has to do that. Okay. And for example, we also set calibration. As you know, in MTTS, we also do that kind of thing. But I still believe it should there is only two points which one mentioned by Uma, other one by Shailesh. I don't very much agree with that. Okay, I mean they are correct at the very what you call universal view, but I don't personally believe in that. For example, Uma said that mathematics training should help us to ask correct questions. For me, all questions are correct. Only answers can be stupid. Okay. So the problem is once you say you want to ask correct question, you are kind of uh, essentially putting a hurdle for a student, for a beginner. Okay. He may not know whether it's going to be correct or not correct. So he will never ask. So all questions are okay. And the second thing is about Silas thing. This is one common misconception. Okay. People even in the educational field think about, unless it's especially mathematics, it has become almost a religious thing. If I read a book, unless I understood the first 10 pages, I should not go to 11th page. Never ever in any life it works. Even for the best mathematician, that's not the way. What you have is you have certain level of confidence. You think you had understood reasonably well. When necessary, you can come back and relearn it. Okay, then you progress. Otherwise, it's like, I will wait for the waves to stop, then I will take a bath in the sea. Okay, it's endless. So, certain level of competence and also your confidence level is what is needed to go forge ahead. And you should also have the less ego. Once you think that you are not understood, then you go back and relearn again. Okay, that's the only thing, because that's one stumbling block, especially it's fostered by or inculcated into our mind or seeded in our mind by the mathematics teachers. Okay, these are the only 2 points. Otherwise, there's a really wonderful talk, and it was really good. There is only 2 things. I do not know how long I will be able to continue, which is slightly out of the context, which I mentioned during our preliminary meeting, which I would like to re-emphasize 2 points. See, as I said, there is a level of thinking is different. One is application oriented, theory oriented. And for example, to be my personal side, I will say, I'm reasonably good in critical thinking, okay, and my pure mathematical thinking, abstract thinking. But computational algorithm thinking, I am very weak. Okay, if you ask me to write a 10-line code, it may take an hour for me to do that possibly. Okay, it's not easy one. Okay, so that kind of thinking should be taught in a very young age. Okay, and that's where in the preliminary meeting I was mentioning about a book which was published by MIT, and just you cannot believe, I could not trace it at all. All of a sudden today it appeared. Okay, if you allow me, can I share? Are you able to hear me?
Yes, sir. Yes,
I
sir.
can hear you. You can share.
Okay. That's why I want. Okay, right. I hope I got it correct. Let me just check. Yeah. Which one is this? I do not know where to look at it. Yeah, let me just give a minute. Whiteboard, desktop. Yeah, I think.
Yeah.
Are you able to see this?
Yes, sir.
Yeah, we can see that.
Yeah. By Denning and Tedre, computational thinking. This is the book. which I saw about 3 or 4 months ago. I totally lost it. And all of a sudden, about 2 hours ago, I got it. Okay. And this talks about from what they call Americans call K-12 level itself, they have to teach.
Yep.
Okay. This is what I was saying about. And this kind of computational thinking should be taught. And even at the what I said about the group and discussions or projects should be done at even at a school level. Okay, because students, you will see that they improve. There are three things which in my life of for about 50 years of teaching, okay, since BSc onwards I have been teaching. What I found is that students are free to discuss anything with their classmates, with their peers. Okay, so the best thing is to kind of encourage group discussions and group projects at a very young age. Okay, and the third thing I would like to say is about 2 weeks ago, all of you might have read, China has made compulsory from age of 6 or 6 standard onwards, a compulsory curriculum. So if you have to kind of really compete with the world and be relevant in the world and not to be a slave race, okay, we have to get into the act much earlier and much faster with no ideological considerations. Okay, that's my fervent appeal to all of you. Okay, that's it. Thank you.
Okay, thank you, sir. Dr. Kumar, you raised your hand, so you
Yeah,
want.
I just wanted to clarify when I said ask the right question, what I meant is that if a student does something wrong, then the teacher can train them to ask the right questions so that they can get to the answer or kind of realize their uh, thought process may not have been correct, and then they can correct themselves. And I feel like that's relevant in the age of AI because the AI can make mistakes too. And then the students should know how to test whether what the AI is giving is the right answer, or like how would they approach thinking through checking the AI's whether the AI's answer is right or not. That's what I meant by kind of help them.
Thank you, Kumar. And yeah, okay. So, Pranav, would you like to add something to this? Covered everything? Okay, so let's go ahead to the next agenda point. How should teaching and assessment method be reorganized in light of AI advancement? So
There is no audio. Is there an audio
Hello.
Audio? Hello?
Yeah. Can you hear?
Hello.
Yeah, now we can, but earlier there was nothing for a few seconds.
We were changing something.
Okay.
Yes.
Yeah.
Yeah. Thank you for giving me the opportunity. So the first thing we have to realize as teachers, and I'm teaching in the university system for very long, that we are no longer the information providers, because the information is available at the tips of the finger. And when we were students, we had a very different scenario. And as I think most of our previous panelists have already told, and as Professor Kumaresan was reiterating, the two things will become very important. One is this sort of algorithmic thinking. So converting the ideas into computational procedures. That is where I think we need to train the students. And second is the critical thinking, which I think Dr. Uma and Dr. Shailesh and the other panelists also have spoken about. And so the best way, I think, in the classrooms, we can introduce concepts like they were saying project-based learning, where people have hands-on experience, and so that they can relate to the concepts of what they are learning. The second thing is also that flipped classroom. Sometimes if we allow the students to become teachers, and they start teaching us about the concepts, I think they learn better. Because if it's just a flow of information from one side to the other, the learning is not complete. So this concept of flipped classroom, and we've tested that in the universities at different levels. Of course, you can't start at the school level, but when they are a little matured, you can start those things. And then when you are teaching undergraduates and masters, I think we have to have mentors, because for them, it is more important to clear their doubts and guide them, as we see also in the PhD research programs, that we need to act as mentors. And sometimes that's where the industry can come in, because at present, the industry academia connect is not very strong in most of the colleges and universities. But people coming from the industry where they're working with relevant problems, if they come and share their experience and then become mentors to these projects, then I think the concepts that they learn in the book or in the class become more effective, because they learn to apply in the real world problems. So I wanted to quote Professor Manjul Bhargav, who's of course a field medalist, and he worked very closely with the new education policy. So he was in India at the ICTS Bangalore campus for more than 12 months as a part of the 12-member committee. And he made a very nice observation. So he said that mathematics in India has been reduced to a performance test, but math is not a race. It's a form of thinking, a philosophy, and a way to engage with complexity. That is very important. If we just, maths is used for clearing the competitive exams or getting admission, then you learn the skills. And I'm sure the class 12 students who have just qualified the IIT JEE would know better, tricks to solve the integration problems than I do. But if you, almost all of them, and I don't know, I can solve as well as them. But that's not what maths is about. The maths is about the conceptual thinking and then applying it. And that's where we need to. And that's what we are seeing, that now, if AI, ChatGPT, DeepSeek, whatever you're using, they'll be able to compute or solve the problems even faster, probably faster than any human being, and without making mistakes. They are learning, and soon they will come up with almost foolproof systems. Now, how will our role as teachers be still relevant? So I think we need to think and change the mindset of the teachers as well. And as we were discussing in the pre-panel thing, that luckily I've taught many years in France, and I used to see that the best students still opt for mathematics, physics, and their master's level students can beat any of my PhD final year scholars. It's not because they are more brilliant or more hardworking, but the way they are trained and the way they are asked to think originally and independently. So what I have seen in the Indian education is we have a more spoon-feeding system. And then the students, they are so used to, just getting the information and just, rote learning or memorizing. And the way we are assessing them is just on the written exam base. That's not how the, the concepts get tested. So I think, like Dr. Kumar, Dr. Shailesh also emphasized on the thing that the way we assess the students have to change considerably. And for that, we need to upskill the teachers. We cannot just let the teachers who are teaching in one way for the last 30 years, and suddenly that AI has come, you have to forget everything that you have taught and relearn. It will take time in the changing of mindset. And that's where I think we also have a very critical role to play. So these are some of my initial thoughts. And I think then once we have the discussion or open to questions from the audience, I'll be able to give some more suggestions or thoughts.
Okay, so thank you, sir. And if any panelist would like to add to what Professor Anirban has said in light of question number 4, sure, Mayank, please.
Hello. Yeah. So this question is very sort of near and dear to me, and I would leave AI out from this question for now. in general, I've been sort of grappling with this. How should teaching and assessment methods be reorganized in general in teaching? And I think this is more of a cultural thing, but one thing that I've noticed with the way we sort of impart learning, it's very grade driven here in India. And it's the mindset of the students right from the beginning that they just want to excel in that particular course, get certain grades, and that's how limited the worldview is. So we are, let's say, not taught that something like plagiarism is a sin. Whereas, like in the West, students are fine not getting the best of the grades, but they wouldn't still cheat on exams or homeworks or otherwise. So one example is I was recently talking to someone in the industrial engineering OR department at IIT Bombay, and they had their PhD entrance exam, and they thought of giving it as a take-home exam where like students would work on some research project. And everyone ended up making the same mistake on one particular problem, and it so turned out that ChatGPT made the same mistake. So everyone like sort of directly went to ChatGPT instead of trying to work on the problem, even though like they were given the freedom to work on it for a day and like be critical about their methodologies and so on. So I'm not really sure like if the mindset needs to be changed, it has to be changed at elementary school level, then at the maybe level of like higher secondary or college and so on, right? So one thing is that we need the mindset change before we can talk about changing assessment methods and so on. So regardless of whatever, I think we have learned to game the system in general. So regardless of whatever teaching and assessment method I believe we come up with, then people will always find ways to game it because they only care about grades. So that needs to be, I think, communicated to students well. Maybe they should. People have tried flipping classroom things. So a lot of students they would end up watching the lectures and they wouldn't show up in class. I feel that in class discussion is the most important thing. Sometimes even the rest of the students they ask certain questions which faculty would find it difficult to answer it right away. And I enjoy that kind of interaction in classes. So there is no sort of I would say second way or maybe a shortcut to that kind of learning where you also learn from your peers. So flipped classroom we have tried, and very few people would have any questions. They would only watch the lectures towards the closer to exams and so on. So I'm really not sure. Maybe like in the light of AI advancements or without the light of AI advancements, if without changing this mindset, we can really be. I have in fact also tried, let's say, in homeworks, you can insert in your PDF in white text that you have to cite some random lemma in order to receive maximum credit. And ChatGPT would generate answer where it would randomly cite lemma. So there are these ways you can catch students, but I don't think that, I mean, you really, I mean, the objective should be to really find students who are good and who are not good and accordingly grade them. If we can somehow change this mindset of students, that would be the best form of teaching assessment, and I think it's this. I think it's independent of AI, in my opinion. So.
Yeah, Dr. Shailesh, you raised your hand.
Yeah. Thank you. So two things I wanted to add. So one is, in the post-AI world, what role will people play is a very important question. So let me give an example from medical domain, right? Imagine that we have built an AI that can do the diagnosis of a patient. We have built an AI that can look at X-rays and all of that. In that world, what role does a human doctor or a radiologist play is the role of what I call a curator, not a creator, right? So now a doctor is not doing the diagnosis. Doctor is looking at the AI's diagnosis and deciding whether it is correct or not, right? Similarly, radiologist is not doing the radiology work. He's looking at the report that AI has generated and doing the curation and approval. So this is a very big transition that is happening, which and same thing in any other field. So, a musician will do the same thing. He will curate the music produced by AI. News writer will do the curation of the news article produced by AI. This is a very big shift that is happening in our relationship with our work and AI sitting in between us and our work. Now, what does that mean? For example, in education itself. So I was in Dubai, there was a conference and there was a CEO of OpenStack was there, and he was asked a very good question that now that AI is doing software engineering or not software coding, what is going to happen to the role of software engineers? And he had a very insightful answer. He said, look, if the role of a new software engineer is to curate what an AI has produced, that software engineer has to be better than the AI in producing software. And that is the new dilemma of education. While we are learning, we are not going to be better than AI, but eventually the people who will sustain a job in any field, whether you're an expert radiologist, expert doctor, or an expert mathematician, you have to be better than AI because your role is to curate the output of AI. So this is the new context in which we should look at education now. And the second theme is, when calculators came, did we stop teaching kids how to add and multiply numbers? We did not, right? Similarly, when AI software coding systems have come, are we going to stop teaching kids how to do programming? Not. And the reason is fundamental skills of thinking and computation will always be there. They are the foundations. But the end goal is not now to compete with each other. So we, like IITs or job rat race, we are not going to compete with each other. We are now competing with AI in some sense. And if that is the goal, we should both use AI to help us become better and then be at the level where we can curate the output of AI. On the assessment side, I'll just give an anecdotal example. I was in UT Austin and I had a great privilege to take a class with Professor Dijkstra's. We all know the Dijkstra's algorithm on shortest path. And his method of assessment was he'll bring each graduate student for a couple of hours. He'll give them an unsolved computer science problem. And he knows that it is an unsolved problem, but he will watch how you are solving it. He will give you little hints here and there and just see whether you are able to apply what you have learned to solve an unsolved problem. And that is how he would judge the student, right? So I think there's a lot of lesson in how we should think about assessment at the highest level, right? Yeah, those were the 2 points I wanted to make. Thank you.
Thank you, Dr. Shailesh. Yeah, I think most of the panelists are saying that we have to reimagine, rethink our assessment, possibly get rid of the grades. It's difficult because the size of the population that we have. But anyway, these are the things we have to know. I tried saying that let's not fail any student. Anybody who has attended, let us give the pass grade. But my colleagues did not agree. So still we have the exam. Though I was the chair of that committee, but leave that aside. Anyway, let's move ahead to the question number 5. What pedagogical strategies are best suited to address interdisciplinary challenges posed by AI? And I think Professor Anirban, he has worked in a lot of disciplines. So let me start with him to add to this points.
Thank you, Professor Ajit. I think yesterday I gave several instances where we were trying to apply the well-known concepts in mathematics like differential geometry or topological data analysis, algebraic topology, to real-world problems. So it was not only connecting the dots between the different parts in mathematics, which is the interdisciplinary thing, also across disciplines, multidisciplinary. So you take some problems in economics or in biology or in sociology or in ecology, and then you try to use these mathematical techniques to show how these can be relevant and where can we apply. So often when we are driving a car, we do not worry about the machinery of the car and rather focus on driving. But it's important to know the tools, but it's also I'm using the car to reach my destination. So both things are important. And in India, somehow we have seen, and I'm quoting the former Vice President of TCS Innovation Lab, Dr. Gautam Shroff. He and I used to work closely when I was a consultant at TCS. That he was saying that we hired the best engineers also from the IITs, and they can code fantastically, but they don't know how to think critically and form the right questions. And that's where I think that Dr. Shailesh, Dr. Kumaresan, and Dr. Kumar have also touched upon these things, that, you need to have that, what is my problem, break it up into smaller things, reduce it, and then use AI coding everything else. Now, there are two other things I wanted to touch upon when we are talking about the pedagogical teaching methods. One is we also have to realize that in India, we have so much diversity in culture, but also there is a difference in access to the sources. So as far as equity and equality is concerned, what we are seeing, and I'm saying that when I'm talking to the social scientists, that AI is actually increasing the inequality. Why? Because not everybody has a smartphone, or not everybody has a laptop computer with internet connection, or can use ChatGPT. Now, what happens to millions of students who do not have access to such modern technology? Would they be left far behind? So we have to think in that respect. The second is what Mayank touched upon is human ethics, but also AI ethics. And I think we are not thinking so well, and there are a lot of concerns about AI ethics. So whenever we are using AI, we have to be very conscious about the AI ethics part. And the last part, I think, where AI can also help is that suppose a child, we all grow up with our mother tongue, and then we are introduced to our languages, and then often English or Hindi or in South Indian tongue. These are the major languages where we are teaching. And with AI, now it can be, one material can be easily translated or brought to a student in his or her mother tongue. And that's where I think AI should be used, and the regional languages can use it to teach the concepts better. So I think that will also reduce the inequality in terms of, because I was talking to a student yesterday, and he's sitting here, and he said that he came from Orissa, and the first semester he had difficulty here because it's not so easy to start learning in English and in a different culture. And that is a problem which many of our students face when they move from one part of India to another part of India. And I think that's where AI and other tools can also assist, and we can use these modern techniques to equip the students. Okay, so these are some of the initial thoughts again I wanted to read.
Okay, thank you. And do you want to add to this?
Can I add something?
Just a brief point, and I think I have sort of benefited immensely from that. I think every student, regardless of their core discipline, they should take courses in other departments too. When I was a grad student, I ended up taking close to 26 courses across all departments, and that has helped me. So sometimes they may be directly related to your research, may not be directly related to your research, but often you would find these loose connections between different disciplines. And you know that today's research or otherwise, like today's problems are very interdisciplinary. And maybe you may not be immediately benefited from those courses, and you should never look at courses or learning otherwise from the point of view of direct benefit or otherwise. But at some point, I'm pretty sure that they are going to come up in one way or the other. So attend different seminars, take as many courses as you can across different departments, even if they are remotely sort of related to your area. And I'm pretty sure that you will benefit immensely from the learning that you're going to get from those. And that sort of addresses to a great deal, addresses the interdisciplinary aspect of research and problems in journals that we are now facing. So,
thank you. Does anybody want to add to this?
Yes, just a couple of things.
Yeah, please.
One is, I agree with Professor Anirban. Democratization of education is very important, right? Today, it is very different for different strata of society, tier 1, tier 2, 3 cities. And I think one of the great promises of technology, right, with everybody having a smartphone and connectivity and AI, democratization of AI will be possible. It is not that the laws like, Sarva Shiksha Abhiyan is not going to make education democratized, but technology is going to make education democratized. So that is one theme that should be part of our curriculum. And obviously, we are doing a lot in terms of creating books in all the languages and making sure education is cheap, but quality also has to come up, right? Second is, I think, Professor mentioned about the interdisciplinary nature of education. And that is very important. How do we break the silos between departments and teach things across departments? And the more and more interdisciplinary things we do, the better our number of edges in the brain will increase, not just the number of nodes. And this is, again, very important. The third is, I've developed a couple of courses. One is called The Art of Thinking, and a new course I'm developing, it's called Hammers, Nails, and Chairs. Hammers are the tools we learn. Nails are the use cases that we solve, and chairs are the solutions we build for society. And either we are teaching hammers on one side and saying, here are the tools, this is how you do calculus and quadratic equation. Or in business schools, we are talking about chairs and saying, these are the different problems in different industries. And we are not bridging the gap. So the IIT types, the engineering and the science and technology people are learning those skills, and the domain people who are learning business school, HR, operations and all that, they are learning different skills and they are not coming together. This is another great example of where we are missing the boat, unless, and then we are asked to bring them together and talk to each other and solve a business problem. And it is not happening because 4 years of IIT and 2 years of MBA, they have made them into two different people. They don't even know how to talk to each other anymore. So one of the great things that will happen is in every domain, even in chemical engineering or architecture, if we start teaching common things like math, computer science, and AI at the right level of abstraction, that is the thing. I think we get carried away by, no, if you say math, you mean all the detailed math. No, level of abstraction of computer science, right level of abstraction in AI, right level of abstraction in math, taught to every school. Agriculture should know how AI works, computer science works, sensors work. Lawyers should know how all this works. Doctors should know how all this works. So I think we need a complete revamp of education, looking at the interdisciplinary and creating a common core curriculum that should be part of everybody's thing, so that we can think in a more freely, free fashion and connect the dots between hammers, nails, and chairs. Yeah, thank you.
Thank you, Dr. Shailesh. I think we would like to give some time to the audience. So that quickly we go to the next agenda point, that is 6, regarding what national policy interventions are required to support effective AI integration in mathematics education. So first, I would like to maybe hear from Dr. Kumar if there are certain policies in US which she has come across or in her university, then we will ask other panelists. Dr. Kumar, can you share something? Yeah, please go ahead.
Yeah. So actually, it is very new, and these policies are still being developed. But there is an AI ethics policy in the works, and we've been asked to incorporate a AI usage policy in our syllabus, and the university has given us some guidelines. But incorporating AI in the classroom has been a little challenge because it requires funds if you're going to build personalized chatbots for your own classroom. Then it's going to be interacting with OpenAI at the back. So you do need some tokens and credits to set that up. So there is some funding involved in there. But more than the funding, the stumbling block at many universities is about the privacy issues with using OpenAI. And if students start using these chatbots or OpenAI or ChatGPT or any of these GPTs that are there in a web-based fashion, the student data will be stored on OpenAI servers, and nobody knows how OpenAI is using it. So from a privacy standpoint, the university is hesitant to do it because there are some federal laws in place that don't allow student data to be shared widely. So I think, I mean, these policies are in the work, and there's a cost perspective to incorporating AI in the classroom, and there is also a privacy perspective. But universities are working with OpenAI to come up with a contract as to how their student data will be stored, where it will be stored, how it will be used, or how it will not be used. So those are things in the pipeline, but it's not yet. I think by fall of 2025, we'll have something where we could incorporate AI tools in the classroom. But as of now, we don't have a policy at our university. Although there are universities where they've built custom chatbots, and the university has taken on the liability to for the students to use that custom chatbot after having gotten clearance between the university legal counsel and OpenAI. So
Okay.
thank you.
Thank you, Dr. Kumar. Yeah, thank you. Professor Kumaresan, do you have some thoughts on what policy that the government can possibly have for integrating?
I do have, but I'm a bit tired, so I think on some other occasion.
We understand, sir. No problem. Professor Anirban, since you have also worked closely with
Thank you. Yeah. So I think one is we saw, and I mentioned yesterday in the lecture, when DeepSeek was launched, they wiped out 500 or 600 billion of NVIDIA. Of course, they showed that, with less sophisticated GPUs, or not even GPUs, CPUs, they can do that. But the main thing which shook the world was also because they made it free and open source. And as an advocate of open science and open source, I think slowly we will have to come to a place where we give importance, to AI, which would be available to everyone to reduce also the equality and inequity and inequality that we're talking about. I also wanted to remind that I was working on a project, and most of the AI models in the big companies, and I heard about a concept called WEIRD, WEIRD. I don't know if everybody is aware. So it's Western, educated, industrialized, rich, democratic. WEIRD. Okay, once more I repeat: Western, educated, industrialized, rich, and democratic. So all the models are trained with those type of cases, and the way, if we implement them blindly in India, we'll run into problem. So I think the first thing the government has to do is make it regionalized and suited for Indian applications. And I think that's where the industry has a large role to play. And then I was telling that, as most of us said, that it's a building of culture that we have to, make a change. So not only the teachers and students, but also the mindset of parents. Because in India, we have a lot of influence of the parents. And I think some places we have to segregate, the influence or the interference. I have seen that even at the master's level or PhD level, parents come and, sort of influence their kids towards what they think, they are right. But I think that independence has to be there. And so what we need to teach the students are also to become independent at a much younger stage. I see that is a difference between the developed countries and our developing countries. Probably it's an effect of the society which cannot be changed so overnight, but definitely as educators, as teachers in schools, colleges, and universities, we have to play an important role. Now, I also often mention that there is a difference between a coaching institute, a college, and a university. A coaching institute, helps you to only gain skills to probably crack one exam or two. A college is where you are giving some information, and a university is where knowledge is created. And we often forget that role, when we're teaching, and they have to be integrated. If we leave the teachers in the colleges away from research, then their knowledge is not upscale, and they are sometimes outdated. So we have to have an integration between all this, and also bridge the gap between industry and academia. And that's where the government has to play a very important role. Somehow, I remember that in France, if the industry takes an intern from the university, then taxes are, reduced. So that incentivizes the industry to take students. Now, the students also get higher scales when they work in the industry, and it's a less burden to the university. Yeah, so that type of policies have to be made where we facilitate both the industry and the academia, or we incentivize both sides. Otherwise, we won't be able to work hand in hand. So that is some, again, thought which I wanted to share.
Thank you very much. Very nice point. Dr. Shailesh, maybe in, let us say, 60 seconds, if you can make some points.
Yeah. So I think one of the areas that is going to become very, very important is the ethics in AI. And I just want to talk a little bit about that. So, human race has a tendency to first abuse a new technology before we start using it, right? And that's what we did with the nuclear technology. We bombed 2 cities, then we realized we can build electricity. We misuse the internet first, then we realized we can use it for education. We misuse Gmail for spam, and then we realized we can use it for something else, right? So I think AI is going through the same thing. We are starting to see many, many misuses of technology. Especially, deep fakes and voices and all the wrong things that we are doing. And strong regulation is needed in all of these areas. Otherwise, AI has a tendency to be very innocent. It doesn't have a moral compass. It will do whatever we tell it to do. And it will not know that it is doing harm or good to society, because it's the people behind them that are causing good harm. So one of the double-edged sword that open source movements do is open source movements allow sophisticated technologies in the hands of everyone. And you all need just 1 or 2 people to misuse that technology and destroy what we have created. So I think the whole ethical background, the value system of education, should I do it? Could I do it? Are 2 important questions. And the first question is, should I do it? Second question is, could I do it? And I think this kind of education should always be part of our thing. With every concept we teach, we should always have this in the background, that there are good use cases and bad use cases of everything you are learning. And who is going to decide what to choose is up to you. And that is the human element behind all this technology that we are creating. Thank you.
Okay. Thank you very much. I think we have covered all the points. I'm sure there are lots of questions among the audience. So I would like to open the floor, and just volunteers, please pass on the mics. And among the panelists, whoever wants to respond, please do it quickly, and please be very precise with your question.
I don't have a question. I have just one moment regarding the computational thinking. MIT, there is a course on computational thinking. It's a fairly old and very well understood, well described course on computational thinking. It's available on YouTube. There, all codes are available. The entire course material is available online. It's a very popular course in MIT, run by Professor Anirban, who is a mathematics professor at MIT and also the inventor of Julia program.
Okay, thank you, Dr. Swamy. Yeah.
So, my question is to Professor Anirban. Might be silly, but I must. If my PhD student is working on Riemann hypothesis or Mealer-Stokes equation, and AI comes with a correct solution. So who gets the $1 million prize?
Computer scientists who develop AI, who created that mathematics, for example,
I think I have already Professor Kumaresan mentioned that let's get rid of the credits.
it's not a great surprise.
Yeah.
You have to create your view.
Yeah. So let us take some more questions and then we'll yeah. And also it's true to all those who have joined online. If they have some questions, we can take them as well.
I would just like to make one statement because
No, please go ahead.
no, because as mathematics teacher with all these new progresses and whatever what I feel is the first thing I tell myself is I'm going to be better than AI. That is what I was very happy to hear one of the panelists who say, because how do you distinguish otherwise whatever information you're going to get or use is right or wrong? So basically it means that we have to still give importance to concept, still do things the way we have been doing. There is nothing wrong with it, but also make sure that you are connecting to what is happening around, so that you also tell the students that you do all these things, but you still have to learn what we have been looking for years. And the goal should be to be better than that's all.
Yeah, and behind is possible man.
Yeah, so, this is regarding that question that was asked by someone about Riemann hypothesis. So I asked the same question to ChatGPT, and here is the answer. If you solve the Riemann hypothesis with my help, you get the $1 million prize, because I am a tool, not a person. I can assist, guide, and brainstorm with you, but I cannot submit proofs or hold rights. Any insights or outputs I provided are considered part of your process. You are the one doing the interpreting, verifying, and putting the proof together. So that's it.
Thank you very much.
Because like how does AI enable you to think critically? But this approach that will never happen, because an MSc graduate in mathematics will always, classically he is known to go for academics or research. Other fields are okay, but now critically, how AI is going to help a research student or MSc mathematics student to enable thinking or build logic, for instance.
Does anybody wants to respond?
One thing I think, I remember I've been seeing these old photos when calculators were invented, then there was a lot of obstruction in America that many jobs would be lost. Then when computers were introduced in India, and I remember in the spell there were several strikes, people were thinking that they would lose jobs. And at present, we are living in that crisis when they're thinking that AI will replace all of us and we get scared. I think what we should be able to use these tools for better use. And as Dr. Shailesh said, we can use and we can abuse. Like nuclear energy, if it's abused, it's a nuclear bomb, and if it's used well, it's a power source of energy. Now, how we, and I mentioned that yesterday, that New York Times article, that how we will use AI will determine in which direction we're pushing it. And it a lot depends on us how we are using. Now, if we use it also for critical thinking, I think, like if I want to use, like earlier, if I would like to do a background literature search for my research, I would go to Google, type some keywords, and get some papers. Now I do the same thing in ChatGPT. it will actually not only get the papers, but will give you the relevant portions also. So I don't have to read the entire article. And I can ask it to summarize, give me the key points or the open questions or the drawbacks of the paper. It does it in a second. So if I am an expert, it becomes very easy because I also know how to distinguish between what is right and what is wrong because I'm an expert. Now that's why the students have to be careful that if they just take it blindly from ChatGPT, they may end up with something wrong. So as teachers, we have to educate them that be cautious when you are using these tools. You can get correct answers, but you can also get wrong answers and hallucinations. But if you can use it well, I can use it for critical thinking, asking the right questions, formulating the research questions, much quicker. That we have already tested. And how I can read ChatGPT, if you tell it to give 5 points, it will give you 5 points. You tell it to give it 3 points, it will give it 3 points. If you tell them, can you now tell which is more important, which is a priority, then it fails. Because what it is doing is it's learning from, it's a statistical model and statistical learning method. It just learns. It cannot prioritize. Whereas as an expert, I know this is more important and this should be coming first, then this, then this, then this. So that as an expert, I know. And that's why I would always be better than probably a ChatGPT. And some student who is using ChatGPT blindly, I can catch very easily.
Okay, thank you.
Okay, so I just have a question. What is your opinion about AI-based classrooms in future for mathematics in schools and colleges? The teacher only will be in the backstage and will check whether what the AI is actually is right or wrong.
We have to also remember that we are no longer information providers. Earlier, we used to go to a classroom and listen to a teacher because we didn't have any access to information. There were no books, no computers, no libraries, or we used to be very difficult to access those things. Now it's in our phone. Everybody has a phone and all the information is available. Now, how do I use it in a classroom? I'm sure that's what I'm saying, that the teacher has to learn how to engage a student, how to ask or help it to think critically and ask the right questions, show the connections between the problems and the solutions, links between the different concepts, how they can be applied. So these type of things, so we have to give the importance of change the priority, that's slightly different. That's my experience of that, Professor.
Okay. I think there are some questions on the Zoom, but probably it has already been answered by Dr. Shailesh. So we'll not.
I don't think there's any other question after that.
Okay, fine. So it is already answered. So I think quickly one more. Switch on your mic.
You can speak loudly. You
can speak loud. So do you have a question or you have comments? So please.
We have exams. We have if we we need to learn more mathematics and just to make ourselves stand out in front of people coming from other domains as well.
Yeah, so
then so I guess the point when we discussed that, it was in the context of incorporating AI into the curriculum of mathematics. So in that context, like we start with the problem in AI and then you can teach the same concept that you want to teach in calculus. When I said like it should not be taught in isolation, what I really meant is that calculus in itself is not an isolated topic. Like this is what you need to do. Maybe this is how you take back like derivatives and so on. The moment you sort of show that back propagation, like how effective back propagation is and how it can sort of accelerate the training of neural networks, let's say. It is really, I mean, product rule is at the end what you are like basically applying to the model itself, right? So you can show the application of it, and that sort of really connects with students directly. Then sort of teaching something like a product rule, and where students are not really able to appreciate the concept. So that's what we meant when we said it should be taught in not in isolation, but with keeping some certain application in mind.
Thank you, Mayank.
And I have to agree. That's why just initially I thought of just attending for 15-20 minutes and we'll go, but I've stayed for more than 2 hours, 2.5 hours now. I think one we must get as teachers in our mind that NEP or whatever the discussion which happened today, our job has become increasingly more challenging. Look at the students, right? Students are not at all. In fact, if you look at the NEP syllabus, the syllabus is much less as compared to what they used to study. The way we implement NEP, our job has increased. So, as a teacher, the kind of rate of renewal of our skill set which is required has significantly to be at a faster rate. And I think AI is going to definitely help us in improving that skill set significantly at a much faster rate. And if you look at AI that way, you will be able to use AI in the right spirit and in the right manner, which will help the teacher disseminating that knowledge to the student. I will just quote 4 basic objectives which I keep on repeating again and again every forum. Every academic has 4 objectives, and that is exactly what Dr. Shailesh Kumar talked about in terms of hammers, nails, and chairs. 4 objectives is first, teaching is primary. Second is interaction with the industry, because that is how we know which problems are relevant, and then you will be able to take those problems for which the solutions are being sought for by the industry. Third is research, so that the research, whatever teaching, research or research outcome which comes out, can be shared with the students immediately rather than you publishing and then students reading it after 1 or 2 years. By the time it has become obsolete. But this is how, so if students are learning from published literature and published books, be sure that whatever they are reading is at least 2 or 3, if not more, years old, and it is not the latest knowledge which is there. So if you are doing research, it is mandatory for you to start sharing that research outcome and results immediately with the students. So first is teaching, second is interaction with the industry, third is research, and fourth is AI is definitely going to train us in terms of being very objective and very, very precise in terms of how we communicate things. AI will not use a single superfluous word. If something can be conveyed in 10 words, it will use 10 words, it will not use the 11th word. And that will also help us to convey our findings to the students in a very precise, unambiguous manner. So that is where also AI is going to help us. And that will also help you in publishing, because most of the papers have a limit in terms of number of words or number of pages. So whatever you want to convey, you have to convey it in those many words. So all these 4 objectives of a teacher, they keep in mind, AI can be used and definitely is a useful tool to be incorporated in our teaching, and we should not be afraid of it. The faster or earlier we learn the AI techniques, better is going to be for us as well as students. So thank you very much. An outstanding panel discussion. I hope you have recorded it and you make it available to everybody. Wonderful. Yes. Thank you, Dr. Shailesh, Dr. Kumaresan. I really appreciate Kumar. Thanks a lot for all your contribution. Thank you.
Thank you very much, sir. And for the public myself, initially I wanted to stay only for half an hour, but I think it was so engaging. But we are already behind the schedule. So my job is to actually summarize the whole thing, but so much that has happened, it is difficult And in fact, my student, my colleague has already given me a big bunch of papers. So I will not get into all these things. I would just like to say that, I mean, the AI is here. It is going to be here. There is no denying we can't say I'm not going to use it. So, but we need to kind of reimagine our teaching, assessment in light of AI, and better, sooner we do, better it is going to be. But it has also opened a lot of opportunities. I think several examples have been mentioned by all the panelists. So it is really wonderful discussion, and we have recorded it. We are going to make it available. We are also going to bring out a summary of this discussion in terms of a document. As I said, in fact, we are also planning to have more discussion with these panelists, not just this. This is not this. Possibly in the beginning, and we are going to look at what best can be done in this. So I am sure all of them would be very happy to contribute in this. So thank you very much once again, and thank you all the audience, including several people who have joined in Zoom session. I think our Zoom capacity is only 100, but I think many more people possibly would have joined. But it was also live streamed in YouTube, so I'm sure it's good. And so at the end, I would like to just offer a small token of appreciation to our panelists, those who have come physically here, and Dr. Shailesh, Dr. Kumaresan, and Dr. Uma. At some stage, we would like to give it to you, possibly when you come here or somewhere in between. So that's what I can say. But yeah, I will do Mayank.
Welcome to this insightful session. I now request Dr. Ajit Kumar to kindly present the moment of keynote. Dr. Mayank, Senior Scientist at TCS Research. Next, Dr. Pranav, Senior Engineer Education Team at MathWorks. Next, we have Dr. Anirban Chakraborti, Professor at JNU. We also have our online panelists, Dr. Professor S.I.W.S, sir, Dr. Shailesh and Dr. Urbana. Thank you to all the esteemed panelists and to our moderator, Dr. Ajit Kumar, for such a rich and forward-thinking discussion. The session brought out valuable insight on the evolving role of mathematics education in an AI-driven world. We hope these perspectives will continue to inspire new ideas as we move ahead in our academic and professional journeys. We will now take a short deep break for 15 minutes. After the break, we will resume with the invited talk session 2B. And also, I request you to explore the Baranwal area for the poster sessions. Thank you so much. We will resume back in sharp next 15 minutes.
All right. Thank you very much for coming. Please come once again. Really, see once again. Something which helps our students.
Thank you very much.
I will ask him to put it in. Just have tea and then.
Yeah, sure. Just combine both. So,
I can reimburse that.
maybe I think it's just
Oh, that is.
Oh, okay. Start video or not? Well, video will not come. Okay, so only. Fine. Just to hold it like this. Okay, on the chat, somebody is written something. Excellent session. Thank you. So you log out from this device. Yeah. Oh, so you logged in from my device only, right? Yes. Okay, okay. Good. Okay, fine.
Good morning to you once again. I welcome you all to session 2A of the conference, themed on geometry and topology. This session will feature a series of invited talks by distinguished speakers from leading institutes. It is my pleasure to invite Dr. Vikram Menzel from Department of Mathematics, ICT Mumbai, to take over and conduct the session. Over to you, sir.
Thanks, Shailesh. Good afternoon, everyone. And I hope you are all as invigorated by the morning session as I am. So let's carry that energy forward to the rest of the conference. It is a great pleasure to introduce Professor Krishnendu Gangopadhyay from ISER Mohali. Professor Gangopadhyay is an expert in the fields of geometry, group theory, and algebra, and he has been working consistently in the interplay between all of these three subjects. So what roughly gets categorized as geometric group theory and low-dimensional topology. He has also worked extensively on understanding the geometry and the symmetries of spaces of negative curvature and non-positive curvature. And it is also a great pleasure to introduce him because he is an old friend. He did his PhD from IIT Bombay under Professor Ravi Kulkarni. We both did our PhDs under Professor Ravi Kulkarni. He had visiting positions and postdoc positions at PIFR and ISI Kolkata. He is, I do not have enough time to list the places where he has been visiting. And he is a very enthusiastic mathematician, a very enthusiastic speaker, and he's going to tell us about the reversibility in geometry.
Okay, so thank you, Vikram, for this kind introduction. It's really a pleasure to come here and see Vikram and Ajit and other friends after a long, long time. Thanks to the organizer for inviting me. I mean, this is the first time I am visiting this place, and it is a pleasure. I mean, I really enjoyed my visit and met many people after 30 years, I think, or 20 years. So I think I am feeling very good after coming here. My visit has been very short, but I am enjoying it. Thank you very much for the invitation and giving me the opportunity to come here and give this talk. So now, as you know, the conference is about computational geometry analysis and machine learning. So that's the kind of topic which is very broad, and I see a lot of lectures on machine learning, artificial intelligence, etc. Now, in my talk, first of all, I am not an expert on machine learning. I have very minimal knowledge about the technical foundation to the subject. I am a mathematician, so my talk will be based mostly on mathematics, on more precisely on pure mathematics. All right, but I have made it very kind of basic so that everybody will be able to understand what I am talking about. Now, whether you do machine learning or applied mathematics or artificial intelligence, basic mathematics has to be the foundation of every subject. Without a fundamental knowledge on basic mathematics, no application or computer machinery can be developed, right? In machine learning, also, I think when you kind of talk about the language a computer can understand, there is a binary code, and there is the underlying symmetry that is always there. And in mathematics, the symmetry is encoded by this abstract object called groups. And when you collect the symmetries, they also kind of give nice geometric structures. In a way, they move, or they, I mean, the way they, the symmetries actually act on spaces, that gives rise to geometry. So this talk is kind of relevant to this workshop. So it will point out some nice application that might occur on this, based on this problem that I am going to speak about. Now, what is the basic problem? So I am assuming everybody knows groups. I don't have to define it. Okay. So now when you take any group, one of the most basic problem in group theory is the conjugacy problem. So you take any two elements in a group when they are conjugate. That means there exists an element K such that G and H are related by like G equal to KH, K inverse. So this is a conjugation act, this is a conjugation operation, and this gives you an equivalence relation on the group. And every equivalence relation gives you a partition of the underlying set into equivalence classes. So you get a partition of G as a disjoint union of conjugacy classes. So this is kind of a very basic consideration. And in undergraduate studies, you may have heard about. Let me change the different color so that you can. So you may heard of something called class equation. So in any undergraduate text, whenever you introduce conjugacy, they talk of class equation. So that counts the number of conjugacy classes in a finite group. Essentially, that counts the number of components this partition has. Okay. So and in geometry, like in classical Euclidean geometry, so like you take the plane. Okay, and then take the transformation, the rigid motions, for example, of the plane. So the rigid motions also forms a group. You call that, I mean, that essentially you can define a concept of a distance on the Euclidean plane, and the rigid motions correspond to the isometry with respect to that distance. So take the group of all isometries. Again, if you compute the conjugacy classes of isometries, they divide this whole group into disjoint conjugacy classes or disjoint sets, and each set corresponds to a special type of dynamical behavior for the isometries. All right. So I will not go into the detail at the moment, but the point is that for geometric purpose, the conjugation action is very important, because it not only gives you a nice partition of the group, but each set in that partition characterizes a nice geometric or dynamical behavior that is helpful in understanding the geometry and dynamics of the group or of the transformation that is available in that particular setup. The same can also be talked about all these machine learning or computational geometry setup. So understanding conjugacy classes is a kind of important problem to understand how the group behave or the group behave as transformations. All right. So the problem I'm going to speak about is related to this conjugation. So the problem is about reversibility. Now, what is reversibility in general? So reversibility means different thing to different people, depending on which area people are looking into. But more or less, in any setup, wherever they call about reversibility, there is an underlying group, and it amounts to the study of those elements in a group which are conjugate to their own inverses. So that means in this partition, you want to understand those conjugacy classes for which CG equal to CG inverse. All right. So that's what reversible means. Now, reversible maps appear naturally in many areas in classical dynamics and physical systems. For example, here is an example, very basic example of a motion of a simple pendulum, which is whose motion is given by this differential equation, where q is the position, p momentum, and k constant. If you consider the solution set, then you can obtain a transformation on the plane which conjugates the solution phi to phi inverse. And you note here tau has order 2 here. That means if you compose tau 2 times, it gives you the identity. So this is a typical example, very basic example, where reversibility occurs in physical system. But here we are looking at reversibility as solutions of a differential equation. You collect the solution, they give you a group. And essentially the solution corresponds to reversible elements in that group. So that way it connects the theory of classical mechanics to reversibility. Now there are other examples also which I will not discuss. Okay, but the point is this is a kind of problem that is implicit in a broad area for mathematics. Okay, so now this is some expert. So this sort of maps appear in the classical work of Birkhoff, Arnold, Smale, Divani, and many others. And also they appear in finite group theory, complex analysis, approximation theory, etc. All right. So now here is a kind of, okay. So one thing I have not said that we have formally defined. Yeah. So let's formally define what is reversibility. So you take an element G in a group G, then we call it strongly reversible or strongly real if G is conjugate to G inverse by an order 2 element, like in the previous example. Okay, so now suppose G inverse is tau G tau inverse, where tau square equal to 1. That means tau inverse is just tau. And then take the composition of tau G twice, you see that's identity. So that means this is also an involution, and G is a product of 2 involutions. So that means every strongly reversible element is a product of 2 order 2 element in the group. And automatically, when it is a product of order 2 element, like if G equal to tau 1, tau 2, where tau 1 and tau 2 are involution, then you can see that, you can see that it is conjugate to its inverse. Because if G is tau 1, tau 2, this is G inverse. Tau 2, tau 1. So strong reversibility means automatically it's a reversible transformation. But in practical purposes, not always the conjugating element can be an involution. So in that case, we call G as reversible. So in other words, strong reversibility implies reversibility, but the converse is not true. Now, what is a basic example of that setup? Let's see. I give somewhere here. Okay, this is a basic example. So a basic example where, So even there are groups where reversible elements also may not be available. For example, you take the group of all rotations. Okay, say cos theta minus sin theta, cos theta. Okay, so take 0 less or equal to theta less or equal to 2 pi. So this group is denoted by SO2. Okay, so now here you can see that these rotations like you take the plane, you have this rotation by an angle theta. If you want to take the inverse, then the rotation is in this side, right? So you need a reflection to conjugate one rotation to the other. But reflection is not available in this group because determinants are 1. So even though there may be reversible element in this group, but there is no strongly reversible element, right? So strong reversibility implies reversibility, but the converse is not true. This is a basic example, and there can be transformation in a group which are also not reversible. One simple example: you consider all transformations of this form of the real line. Okay, then take the translation z goes to z plus 1. This cannot be conjugated to z goes to z minus 1 because the orientation is getting reversed. Now conjugation should preserve the orientation. So there may be non-reversible, there are non-reversible elements in many groups. So because of this reason, if you want to understand reversibility, then the theme is to classify reversible and strongly reversible elements in your favorite group. Now, for finite group, the literature is vast and there are many works. Mostly people have worked on finite group. So they have classified even groups where every element is reversible. However, for infinite group, only a very few families of group where complete and concrete classification is known. Mostly people have investigated when a strongly reversible element is reversible, or whether reversible and strong reversibility are equivalent or not. But what I want, that suppose I give you a group, can you list what are the reversible elements and what are the strongly reversible elements? This investigation has not been investigated for most of the infinite groups that we know until very recently. Okay, so another thing I would like to mention here, just to kind of increase your curiosity or kind of make you aware about the terminology, that there are two more names by which reversible elements are known in the literature. So in this talk, I am calling them reversible, but they are also known as real elements or reciprocal elements. All right. So now, why they are calling reversible elements, that I have already explained. But how come this terminology real came into the picture? All right. So for that, it is essentially the algebraists or the finite group theorists who have used this terminology real elements. Because you take any finite group, then the representations of this group are essentially homomorphisms from G to GLV. All right. So now the trace of this, so chi G rho, this is trace of the representation. Okay. So the real irreducible representations of a finite group corresponds to the representations with real trace. And because of that, this is the old theorem of Frobenius and Schur. There is no ordering here. I just Schur came to my mind first, so don't bother about the ordering here. So this is a classical theorem of Frobenius and Schur that that applies that real irreducible character corresponds to real trace. So because of this motivation, these elements are also known as real elements. When people have called them as real elements when they have tried to generalize this setup from a representation theoretic point of view or classical geometric invariant point of view. All right, and there is another terminology they known which is called as reciprocal element. But I think essentially the term reciprocity is more limited than calling them real or reversible. However, there are a kind of number theoretic consideration, which I would not go into detail, but I will just mention briefly here. So in topology or geometry, so any two-dimensional compact connected surface are, all of you know donuts, right? So they are the building blocks for compact connected two-dimensional surface. So you can cut a small circle from two such donuts, and you can build up surfaces like this and go on. So all compact connected so-called orientable surfaces are modeled on this sort of surfaces. So there is a deep classification of two-dimensional surfaces in geometry. And what is the kind of beautiful fact that when G is greater than equal to 2, okay, so just a minute. So when G is greater than equal to 2, this surface is sigma G, they locally look like a non-Euclidean disk. Well, this is a kind of rough statement. By non-Euclidean disk, I means it's a kind of Euclidean plane, but the straight lines are not straight line here. They are semicircles orthogonal to the boundary axis. So there is this parallel postulate of Euclidean geometry that is violated here. All right. So now there is this group SL2Z, which are 2 by 2 matrices. Okay. So this group plays an important role in this geometry, and there are certain lines which are kind of corresponds to certain elements in this group, and these reversible elements corresponds to those lines which are equivalents to their reverse. All right. So in number theoretic terminology, there is something called reciprocity. So this corresponds to reciprocity of certain quadratic form that came from the work of Gauss. And with this motivation, Peter Sarnak in his article called them as reciprocal elements because they correspond to reciprocal geodesics. So when you look at these elements from an arithmetic viewpoint, they are also known as reciprocal elements. And in the case of this group, something beautiful happened, that when two elements are conjugate, when G is conjugate to their inverse, suppose G is H, G inverse H, then the question of strong reversibility does not occur, because any element that conjugates a reciprocal or reversible element, they are automatically of order 2. So this is kind of nice fact about this group, and that has made it more richer. All right. So there are these three terminology: reversible, real, or reciprocal, that you should keep in mind whenever you search the literature on such elements. Okay. So now here's a broad theme of work which I have already mentioned, that classify reversible and strong reversible elements in your favorite group. Now, yeah. So there is. So with this problem, there is another problem which is related to group theory. So you take any group G, there is a very basic subgroup that is associated to G, that is called the centralizer. That means the centralizer of element A is those elements which commutes with A. Now, you collect the set of all elements G that reverses A. Suppose A is reversible. Okay, suppose A is reversible. Okay, then consider the collection of those elements which reverses A. Now this is a set, this is not a group. But if you take the union of RG with the centralizer of A, that is a group. So this group is called extended centralizer or a reversal. All right. So you can clearly say that this component RG is a coset of this group. In other words, this group epsilon G is a degree 2 extension of the centralizer. So if you find out one element for a reversible element, and if you know the description of the centralizer, you get to know the entire set of reversible elements for a given group. Okay, so whenever you see a reversible element, it is also a related problem to understand the reversing symmetry group. That means the set of transformations that reverses the element A. Okay, so I have 5 minutes. Yeah, okay, all right, fine. So this is also related problem to compute the extended centralizer. All right. So now I have mentioned. So this was very basic. All right. So now I want to tell you about some recent results. But before that, I want to connect this to the theme of the workshop about machine learning. So where machine learning comes into the picture. As I told you, I am not a very expert, but I have recently observed that there are some aspects of machine learning where this investigation of reversibility may play a role, and I will mention one. So in machine learning, one of the key theme is to understand. There is an expert in machine learning here. Who is the expert in machine learning here? There is no one. You know that, okay? Yeah. So please correct me if I am wrong. Okay. So if there is a in machine learning, there is a something called neural network, right? So you can explain to students what is that. Okay, but you are teaching that. Okay. So now in the neural network, what happened? You have input data and you have two output data, F and G. Now you can also talk about reversible neural network. That means you can think of this output data as a transformation which is acting on the neural network, and these colors F and G are essentially reversible elements in the group theory in the underlying group. So you can replace the current theory of neural network by reversible neural network, and some people are already doing that. Okay, so they have developed a network called RevNet, but they are talking about only invertible neural network. But what I am proposing, you can probably try to kind of replace this invertible network by reversible neural network. That means these elements you can replace by reversible elements, which might improve the efficiency of the data, or which might connect to more computational accuracy to some extent. So this is a kind of rough theme that I could think of last night, and I thought I will say it here. So maybe you can ponder on this, and if you find it anything interesting, just write to me, and I will be happy to discuss the mathematical part. Okay, all right. So now I will quickly give you. So this was kind of the theme of the work. But what is going on reversibility? So recently I have been looking at different groups to classify reversible and strongly reversible elements. So I think we have been able to understand many infinite groups and concretely classify them. But here I will not discuss all those things. I will be referring to some very general, very basic group that you know. So first of all, what about reversibility in our very well-known general linear group, which are n by n invertible linear matrices over complex numbers. All right. So in this setup, there are classical results by Unenberger, Eller, and other people, where they have already proven that an element G in the general linear group is reversible if and only if it is strongly reversible. All right. We also know that there is a Jordan decomposition in general linear group, matrix theory, right? So now Jordan normal form and this Jordan form are unique after permutation, etc. So you have A and you have this Jordan normal form. Then essentially, when A is conjugate to A inverse if and only if you have corresponding to every eigenvalue lambda 1, you have a Jordan block of the same size corresponding to an eigenvalue lambda inverse. So that means the Jordan form appears into pairs Jn1 lambda 1 and Jn1 lambda 1 inverse. So that has been noted in this rhythm that an element A with Jordan normal form consisting of these blocks is reversible if and only if you get if and only if the blocks can be partitioned into pairs. So pairs of same size corresponding to eigenvalues lambda and lambda inverse. Okay, so this is a very, and there are also unipotent blocks corresponding to eigenvalue 1, they are automatically reversible. It needs some computation or some analysis, but this is well-known result. Okay, now what about special linearity? If you restrict the general linear group to determine to the group of elements with determinant 1, what can you say about reversibility? Now, if you take an element A, okay, then you can always kind of normalize it to, so suppose A and B are conjugate by an element C, then you can always normalize C so that A and B are conjugate in SLNC. Here A and B are elements from SLNC. Okay, so A, B from the special linear group. Then if A is conjugate to B in general linear group, then A is conjugate to B in special linear group. Which means the classification of reversible element in SLNC follows directly from the classification of reversible elements in general linear group via the Jordan decomposition. No problem. Now, suppose A and A inverse are conjugate. Can you guarantee that this conjugation element is an involution, is an order 2 element? That cannot be guaranteed. So even though classification of reversible element follows from the classification of strongly reversible element, classification of reversible element in general linear group, but the classification of strongly reversible element in the special linear group does not follow from the classification of strongly reversible element in the general linear group, where essentially this result holds. The reversibility and strong reversibility are equivalent. But the same is not true for special linear group. Now, here is the example. Suppose you take the 2 by 2 complex matrices. Take the diagonal matrix R0, 0, R inverse. So this element is reversible. Okay, that you can prove. But you can never take a conjugating element which is the involution. This simple computation demonstrates that. So this kind of demonstrate that there are reversible elements in special linear group which are not strongly reversible, and we ask the question, what are the classification of strong reversible elements? Now, in a recent work with, I think I am out of time, so I will not give you the detail, but in a recent work with Chandan Maiti and Tejbir Lohan, we have sort of answered this question. I will not give you the detail how we have answered this question, but for students, I just want to point out one thing, that, yeah, this is the theorem. Let me first tell you the theorem that if you take a reversible element in SLNC, then it is strongly reversible if and only if certain condition holds. Now, this work is now kind of has been accepted in proceeding of Edinburgh Math Society, and I think it will be appeared online soon. There are also archive version available. You can look at the version if you are interested to know the complete result. But one of the key takeouts from this talk that I want to mention for the students is that you all know Jordan decomposition from a matrix. Now there are other normal forms for matrices as well. Now one of the form that we have used here is called Ware canonical form. Okay, so it's a kind of permutation of the Jordan blocks. So for example, if you have a matrix with Jordan form J, that means you have 4 blocks of this pink, 4 blocks of green size, and 2 orange size. Then like you know, like J1, J2, Jn, etc. Then what we do, you just permute the Jordan blocks and you rearrange them as pink, green, orange, pink, green, orange, pink, green, pink, green, right? So roughly, this gives you the where from, and it's a result that where from is conjugate to the Jordan form. So you can kind of, well, there's some problem here. Well, okay, so I think it is not able to read it somehow. So what I do, I don't know. Anyway, so some problem has occurred to this
class of directed loops, right? So when you're looking at this, the geodesic that you are looking at in the disk, what exactly it corresponds to when you reverse it, that should not correspond. So there are no further questions. Let us thank Krishnendu once again. Thank you.
I would like to request Dr. Vikram Mehta to felicitate Dr. Krishnendu with the token of our appreciation.
Thank you. So, continuing with the theme of geometry, so we have seen one aspect of geometry in Krishnendu's talk. So, I just wanted to mention one thing, that when we usually think of geometry, the thing that we know is what we learn in high school. But what Krishnendu just said, talked about one aspect of geometry which is usually ignored, which is incorporating symmetries or the group structure when you're thinking of geometry. This is an approach that started a century ago by Klein. It's called the Erlanger program, and this has led to many significant developments in the field of geometry. So we are just waiting for our next speaker to come back in. So the other thing about geometry is, so you take a geometric object and you study it in many different ways. One of the things is to study the symmetries of the geometric object and use that to understand the underlying structure. The other aspect is to look at certain differential equations which run on the manifold. What you should think about is, you think of how heat will change the structure of a metal, how heat will change the shape of a metal. So this is another aspect, which is another part where we use techniques of analysis to study the underlying geometric structure. And our next speaker is one of the foremost experts in India in geometric analysis. So next we have Professor Jyotsna Prajapat. She is a professor at the University of Mumbai, Department of Mathematics. She has been an active researcher with many publications in very big journals like the Duke Journal of Mathematics and so on. And her main area of interest is geometric analysis, which is the interplay of partial differential equations and geometry. How you use partial differential equations to understand geometry, and how you use geometric results to understand partial differential. So without further ado, I call upon those to start talking.
Yes, yes. This one. Is that okay, or do you want to use it? Okay.
Just try writing answers.
Just open this.
One
Yeah.
more.
Yes, I'll put this, put your PDF in this.
While he is adjusting, we thank the organizers for giving me this opportunity to give a talk here. Let me.
You have to scroll now.
Fine. I thank the organizers for giving me this opportunity to present talk in this conference. At the onset, let me tell you that I'm not going to do any computation over here, but maybe I will try to show you or at least make you understand that there is importance of understanding various subjects to solve real life problems and the interplay between geometry and partial differential equation, which is generally the language to model real life problems from physics and various fields of sciences. And towards the end, I will also talk little bit about the Heisenberg too, my recent result, just to also show that everything is not Euclidean. I'm very happy with the previous talk because I will, he essentially laid a foundation for a lot of things which I will be using. And yeah, so let me begin. Yeah, one more thing because I believe if this has been streaming, is it streaming? Yeah. So if it is streaming, I only want to be very clear that I'm not going to give complete list of references because it is going to be very, very long. Now, what I'm going to means if I'm referring to some people, means these are the people who are very important for my study and for my growth. And these are the people because of whom I learned this subject and moved ahead in this subject. So I don't need, I don't want to offend anyone or leave out anyone. So I have not really given an exhaustive list of references. Okay. I have too many collaborators and friends to do that. So I prefer not to mention. So let me begin with the technique. Yes, I have written my title is Geometric Techniques in PDE. So what I'm going to speak about is a very specific technique which maybe 20 years ago was used by few people, few groups of mathematicians, but now if you open a PDE book, I have seen that they have a complete section devoted to method of what is called as moving plane. So that is what I'm going to speak about, and that was where I started my PhD research work also. Okay. So where does it all begin with? So it begins with this is not the latest file, but it is fine. So I need to write. I sent 2 files. So okay, the first slide I have written. It starts with works of A.D. Alexandrov. So the title of this slide is Alexandrov's reflection method. Okay, so that is what it is called as. Okay, so Alexandrov's reflection method was what? It started by this mathematician who is Russian, 1958, in series of work which started in 1958, where he he proved this very important result which says that if you have a closed n-dimensional surface in n+1 space of constant scalar curvature, and if K1, K2, Kn are the principal curvatures which are ordered like this, and if phi is a function which is having strict partial derivatives, positive partial derivatives, then it is constant on S, then S has to be a sphere. Okay, so here I'm going to just think, say in very simple language. I'm talking of a domain, and I'm talking of here what I'm saying is it is the boundary of the domain, and what I'm saying is if a function is having positive partial derivatives on that domain, and the domain and the boundary is expressed in the graph of a C2 function, then it is going to be a sphere. So as you see, you have condition only on the principal curvature. You are considering this problem, I have denoted En+1. I am denoting it as En+1. Yeah. Now, what do I mean by this constant curvature space En+1? So first, I want to include the Euclidean space. The curvature of that space is, yes. Some students can say what is the curvature of the Euclidean space? Yeah. Yes, it is 0. Okay. The curvature of the sphere where we stay on Earth, right? It is a sphere, it is +1, and the hyperbolic space, which I believe Dr. Krishnan would probably wanted to use the word, but he did not use the word, is -1, that's negative. He drew a circle and he drew something like that way, that was hyperbolic space. So here these are three standard representatives of constant curvature spaces: Euclidean space, sphere, and hyperbolic space. And he solved this particular result, which says that if you have a boundary of a domain or a domain which satisfies this condition, then it has to be a sphere. And for this purpose, of course, in a sphere, he used this extra condition that the domain should lie in a hemisphere, half sphere. So the consequence of this is then this is how this theorem is usually known, which is called as soap bubble theorem. It says that if you are having a soap bubble, it always is a round bubble connected set. Of course, then soap bubble conjecture is different. You talk about double bubbles and vinegar surfaces, which is different. But simply put, it says that a compact embedded hypersurface in Euclidean space with constant mean curvature. So I wrote a function phi, which was just a function of k1, k2, kn. If I just take it as some function, k1 plus k2 plus kn, it is going to be the mean curvature of the surface. And if the theorem says, so this is how this result is very known. This is how one associates his work with. Okay, I'm sorry. Can I make it? This is so bad. Yeah, full screen. It's okay. I will try to one here. Full screen. Because
Yeah, I'll say that.
yeah, it's fine. Because every time there is a pause, it will be the same screen. So yeah. So yes, so this is what I said, that it is going to be a this is what is called as Alexandrov's soap bubble theorem, and he is famous for that. And one can look at this particular paper, which is published in English. Some of his other works, previous works, are in Russian. So this is a very good reference, which one can see. So yeah, and so let me comment on how and why it works. So I'm talking about the geometry result. Here I need to draw it. I can draw it, right? Yeah. So here what the moving plane or the Alexandrov reflection principle is. So what I'm going to do is I'm going to how do I erase it?
So just press this button there.
Learning experience. Fine. So if I look at this particular domain and what I'm going to do is, yeah, I'm going to move a plane, this is very bad. Okay, I'm going to move a plane in this direction till it starts intersecting the domain. Okay, over here, and now I have to use my imagination. Can I do it here? This is a struggle. I cannot do it. So basically, what I want to, I should have kept a right this one here. It is fine. So I'm not going to try this. Difficult. So here, what I'm trying to say is that I'm going to take a plane which is going to move parallel to a certain direction until it starts cutting the domain. And at each stage, I will have at each stage I will have. At each stage, I will have a part of the original domain which is cut off by the plane. And what I'm going to do is I will compare the reflected domain with the original domain. Next.
You can click on.
Yeah. So and you want to continue doing this. You want to continue doing this, comparing the original domain with the reflected domain. Basically, it is much better for me to illustrate here. If this is a book, I'm going to fold this. Sorry, I will reflect it like this way. I will reflect it like this way. I will reflect it like this way. I will continue till the reflected domain contains. At some point, I'm going to go out. Okay, that is going to be my critical position. Once I reach that critical position, I will use actually analysis to say that in fact these two domains have to coincide, which essentially will give me that my domain is symmetric with respect to this particular plane. Okay, so that is what happens. So that is what is called as Alexandrov's reflection method, where you are comparing the domain which is cut off with its reflected domain, and you continue. So why it works is because the isometries are generated by reflections. We also know that if you have a set which is invariant under isometries, it has to be a ball or a sphere. Okay? So here this is the very basic conceptual idea behind Alexandrov's reflection method. Very simple, but when you come to the critical position, you want to argue symmetry, you want to say that the domains are coinciding. That requires analysis tools, PDE tools, and this is what these are the statements which I have written. These are maximum principles, Hoff lemma, comparison theorem, unique continuation theorem. Means these are some words which appear in PDE. They also appear in complex analysis. So you can think of maximum principle same as how you would use in complex analysis. The maximum is attained on the boundary or minimum is attained on the boundary. So that kind of result is used to prove the symmetry. So let me come to the PDE part, how this method is used. or where it appears basically. So of course the title of this slide I had changed it to the moving plane method. Earlier was Alexandra, but moving plane method. You saw the previous result was 1958. This is result is 1971. This is a seminal paper on in PDE where by James Seren. It will continue to refer it forever, and it talks about a domain and this partial differential equation. Okay, so so you are having a bounded connected domain in Rn, and you are looking at the positive solution of this particular equation. It is Laplace u equal to -1. No non-linearity, nothing. Very simple equation. Now u is 0 on the boundary. That is what is usually called as Dirichlet problem, and the normal derivative is constant. Then we could prove that it is not only the domain is a ball, but u is radially symmetric. So let me say a few words about this problem. He modeled this problem from real life problem where he had to model the flow of a viscous fluid in a tube. So he modeled it. One can look at the literature and see. So it comes from a real life problem, and he used yeah, it's fine. It's okay. So he used for this purpose the same technique as Alexandrov's. So when PD people started to use it, they also started to call it moving plane method. Okay, so that is why, and the techniques used over here is same as Alexandrov. Okay. So then there are slight variations as usual in PD. When you have problems, you try to adjust the conditions and try to see whether you get more result. But also one comment which I want to make is that why it helps to show symmetry of solutions. Okay. Here I said the solution becomes radial. Okay, so of course the domain has to be a ball. That is what we proved. We proved the solution is radial. Once the solution is radial, remember I started with a differential equation in Rn, n dimension. Once the solution is radial, you have reduced the problem to one dimension. Your PDE becomes ODE. You can explicitly write down solutions in many cases. So then that is why there are these slight generalizations. One by Vidasny Nirenberg, and what they did is that if you do away with the normal derivative condition, but you assume that the boundary, assume that the domain itself is a sphere, you still are able to prove that your solution is radial. And myself and Kumaresan had extended the results to hyperbolic space and sphere. So that is Seren's result, and also Vidasny's result. We extended it to hyperbolic space and sphere. Remember, Alexandrov's result was for three spaces, right? It was for Euclidean space, it was for sphere, and it was for hyperbolic space. So the PDE result we extended to those spaces also. And later on, like you can see 1971 and our result is in 1998, and the previous one was in 1958. So there is so much of gaps between this result. And of course, once we did this, and because of this group of people of Nirenberg students and their students, there's a huge group of people who work on moving plane method, and there are lots of applications, lots of variations where they have used this technique to derive symmetry of solutions, sometimes partial symmetry also. Okay. So, and not only to differential equations, also to integral equations. Okay. So, yeah. So let me come to this. What I spoke about now was only about bounded domain. Yeah. What about unbounded domain? If you have a function which is defined on the whole space, how do you deal with it? can you apply moving plane method there? And yes, you can. Let me begin with, so again, I'm talking of origin in geometry, which is about this Yamabe problem, which again says that if you have a compact Riemannian manifold of dimension n greater than p, can you find a metric which is conformal to the given metric with constant scalar curvature, right? You always want to put yourself in nice spaces which are having constant curvature rather than, you don't want to climb up and down the hill, right? You would be very happy if you are on a flat surface or a smooth surface. So here, if you want to talk of constant scalar curvature, again, you are thinking about metrics which are similar to hyperbolic space, sphere, or Euclidean space, the easiest one. And so for the sphere, it would mean that on the sphere you have standard metric, right? Which again everyone knows. Even if people have not taken differential geometry course, everyone knows longitudes and latitudes, right? So you do GPS and everything, right? So that is the metric which one should think of when you are on the sphere. So you can ask this question for sphere itself. If I have a standard metric on a sphere, can I find another metric which is conformal to it? And conformal means preserving angle. Again, it says that most of the terminologies which I will use are the ones you have seen in complex analysis. Okay? So this problem was solved by Obata when he showed that any such metric on standard sphere is going to be obtained by conformal automorphism of sphere. So automorphism again everyone understands. So next. And yeah, coming to PDE, this is what it brings you to, because we know the original problem was on sphere, and we know that using stereographic projection from sphere you can go to plane. Okay, so when I translate the problem to the plane, I'm going to end up with this nice differential equation. Again, people who are studying, focusing only on PDE, have studied this. This is again very important. You have critical exponent, etc., etc. So anyway, again, leaving a whole list of people, I'm just mentioning the initial set of works. And Anirban studied the symmetry of solutions of this equation on the whole space using the moving plane method. And then they initially they had to assume some behavior at infinity, then they removed the behavior at infinity, and it was generalized to infinite cylinders. So this is for unbounded domain. And yeah, you see, here also you have Liouville type of result, which says that if your exponent is less than the critical exponent, the only non-negative solution is going to be 0. Okay? So let me mention in I think 5 minutes more because I want to say what I want to say. So then this is another paper which proved very useful for me. Yeah. So this is what I will try to finish. Okay. So thing is, this technique works. This technique works in Euclidean space. It works in sphere. It works in hyperbolic space. Even when I was a student, people asked me, "What about projective plane?" I don't know. What about complex plane? I don't know. Maybe I know now a little bit, but what I have been working on is Heisenberg group. This is This is very beautiful geometric object for me, and here, if you are not confused by this n, you just think of 3, n equal to 1. So you just think of C cross R. So it is just going to be x plus x1 plus x2, y1 plus y2, and t1 plus t2, and in the last one you are having 2 times imaginary part of z bar, z1 z bar, z2 bar. Okay, and you see this has a group structure, and your dilation is different from the Euclidean space. You are dilating as S, the usual scaling in Z variable, and in T variable, you are having like parabolic. This is what people call parabolic dilution. Yeah. And again, you just think of x is d by dx plus 2y d by dt. Y is d by dy minus 2x d by dt. Okay. And my t is my usual d by dt. Then what I'm doing is the Laplacian delta which I had before, I'm not writing t anywhere over here. I'm just writing it as x square plus y square. There is a problem with this operator because you see, if my point is 0, then I am having only d by dx and d by dy. There is no d by dt which is appearing over here. Okay, so such kind of operators are what are called as sub-elliptic. Okay. So it is not, your operator is not positive definite but positive semi-definite and this particular. Yeah. And then I mentioned Yamabe problem. You have similar problem in complex geometry also. Okay, so for Yamabe problem for sphere was sitting in Rn plus 1 Sn. Here, if you think of this Yamabe problem, you can think of sphere sitting in Cn plus 1. Cn plus 1 has 2n plus 2 dimension, right? And the sphere will be S2n plus 1. It will be odd dimensional sphere. So spheres in complex plane are going to be odd dimensional spheres. And one can have complex geometry over there, and then you can ask the same question that given compact, strictly pseudo-convex CR manifold, find a contact form. So these are not terminologies which I will explain because they are complicated, but one can just relate to what I said for the Euclidean space, and it has similar to the usual scalar curvature. I want constant curvature, scalar pseudo Hermitian constant curvature. A lot of complex analysis over there. And then this problem was solved by these two people in 1987, 1989. And they said, and they showed, just as for the Euclidean, for the Riemannian case, even for this particular problem, CR-Yamabe problem. So CR over here means Cauchy-Riemann, the same Cauchy-Riemann equations which you all are familiar with the word terminology. So here, so these are obtained by automorphisms, CR automorphisms go ahead.
ये मेरे दिमाग में बैठा था क्या बोल रहे हैं किसके साथ आ
सब लोग मुझे
अरे एक सेकेंड आ रहा हूँ मैं ये नोट कर दे
आता कंसे के
बस इस इधर माइक बंद रहेगा माइक आगे चालू करो अच्छा ऑनलाइन हाँ तो स्क्रीन वो कुछ शेयर करेंगे ना वो कुछ शेयर करेंगे हमने पीपीटी नहीं भेजा भेजा तो है लेकिन ये कैसे इधर कैसे चेंज होगा वो कुछ शेयर करेंगे ना इधर नहीं होना है क्या Sorry. Because have you declared this? We are going to change, no? No, it is working. It is working. Now I'm not able to show you. So it does not have a pointer now, so difficult. You can use it if you want. Okay. Otherwise, we have alternative. This system that is how so you will not be present in the speaker. No. He is the speaker. He will be delivering talks. You want some basic notions of the things to write. Only in initial stage. In initial stage. Only 5 minutes. Then later on, all things will go into speaking. Even he can write it on PDF, the ongoing presentation. Is it possible? Connected. You can open in blank sheet. हाँ type C. हाँ एक blank sheet इसमें कर सकते हो क्या लिस्ट? हाँ ना वो करो ये भी कनेक्ट कर सकते हो हाँ दोनों कनेक्ट हो जाएंगे ये तुम ले लो उसका कवर नहीं था अभी कनेक्ट हो थोड़ा लीव होता है रोटेशन में ऑफ करो रोटेशन लॉक का हाँ और इसका लॉक जो है 1 to 6 है 1 2 3 4 5 6 और यार ये अपना आईसीटी का ही है अच्छा आईसीटी का ही उसको कनेक्ट करना पड़ता है क्या इसी रंग की तो वहाँ पे ही कैन राइट एंड यहाँ पे हो गए वो एक इधर वो आ जाएगा और एक इधर ये आ जाएगा I wanted to update my PDF file for presentation. So Dipali, at the last lesson. लॉक कर गया ठीक है फिर वो ये डायरेक्ट इसमें कर सकते हैं पीडीएफ में करेंगे और लोग कुछ लॉक करके क्या है ठीक है पीडीएफ में करो कोई इशू नहीं वो अजीब आदमी है यार नीट जाने वो ऐसा होता है चलते रहता हाँ ऊपर रुक जा सर का जस्ट इंसर्ट वन पेज सर का दो फाइल है वो कौन सा देखना पड़ेगा रे लोकेश वाला वो दो दिख रहे हैं ना तो उसमें से लेटेस्ट कौन सा है वो देखो पूछो ना सर दोनों यूज करना है सबको नहीं हाँ ये होगा ये सची से लेटेस्ट कौन सा फाइल ये फाइल वन बाय this will be second this will be the first okay then this then another so this will be the first yes stability of traction okay so before that I will start with say this card possible calculator is not your regular card if it is working then fine otherwise it is It was working hard. So you can just write it. Can you give me some blanks? Like yes, I can see. For 5 minutes, I will. I will move. Yes, I will sit down. Just open some blanks first, and then yes. Yes. Right. You can write here. When you are done with writing, you can just shift there and start. He'll be here.
Good afternoon, everyone. I welcome you all once again to resume our conference. So let us step back into our conference, where this session will be led by invited speakers. They will be talking about the themes mathematics set in natural sciences. I would like to invite Dr. Goodwans Rijadar to from Department of Mathematics, ICT Mumbai to take over and conduct the session. Over to you.
Thank you. So very good afternoon to all of you. After this delicious food, so we'll have we'll increase the test and digestion process through these different mathematical talks. So today's first talk is going to deliver by Professor Sachin Bhalekar sir. So it gives me immense pleasure to introduce him on this occasion. So Dr. Sachin Bhalekar works as a professor at School of Mathematics and Statistics, University of Hyderabad, India. He's completed his master's from Master and Doctor of Philosophy from Department of Mathematics, University of Pune. His core research area in dynamical systems, fractional differential equations. He has published more than 73 research articles, and he completed 4 research projects funded by NBHM, CSIR, UGC, and SIR. Along with that, he having several collaboration with international collaborators from US, Turkey, Lebanon, and so more. Under his guidance, there are 2 PhD students are completed, 3 are ongoing, and he having credit of different awards received by the Padam Shri late N.S. Venkateshan Gold Medal Award. So he published several books, research articles in a reputed international journal. Also, he is on the different editorial board as in charge editor of the different international journals. So with this introduction, I request Professor Bhalekar sir to take a charge.
Thank you, Dr. Kumar, for a nice introduction. So I'm very happy to visit this prestigious institute first time. The the topic of my talk is discrete dynamical systems or difference equations of fractional order. So I will give you some basic introduction and then I will go to main topic. Let's take it on. Hello. Hi. So dynamical system
Hello everyone. Can you hear me? Syed?
Yes, I can hear you, but I can't see any other people.
Okay, so you can see my video, right?
Yes, I can see your videos. Right.
So
But
just I
it
want to.
seems, yeah, it
Hello,
seems
Syed.
the sessions are delayed by, yeah, hello. It seems sessions are delayed by half an hour. So
Oh,
the first talk in the second session started around
okay. I
2:30.
just need to
So
check right now who is giving the presentation. Just I need to check.
I think Professor Sachin Bhalekar, actually he was giving, but
Sachin
I don't know
Bandekar.
whether he is
That is
placed.
right. So, Syed, you are faculty in which department? Well, math in which university?
Yeah, so I am faculty in mathematics department of IIT Mandi, Himachal
IIT
Pradesh.
Mandi. Oh, okay, okay. I am actually faculty in Chandigarh University, Lucknow, Uttar Pradesh campus. The main campus it
Oh,
is in Mohali. So they are opening a new branch in Lucknow. So I am a faculty.
okay. Oh,
So I
so I think recently they have started, right? I mean, because
yeah
earlier
recent yeah
there was
recent
one campus in Chennai.
yeah recently they have started. Recently they have started. Hello. Integrative.
Hello.
Hello. This is Dr. Samson Das.
Hello, hello, sir. Are you able to hear us?
Yes, yes.
Hello.
I can hear you. I can hear you.
Yes, we can hear you.
Yes.
Hello. Hello.
Hello.
Yeah. The Professor Abbas sir. Hello.
Hello.
Yes, hello. Yeah, I can hear you. Yes.
Yes. Yes.
So we'll begin with the next talk by one of the eminent professor. So first of all, I welcome Professor S.I.W.S for this conference. So let me introduce today's speaker, Professor S.I.W.S. So he is a professor at IIT Mandi. So he is a well-known professor. He works in the different research areas like timescale, series analysis, nonlinear analysis, fractional differential equations, and he having so many publications in national and international reputed journal. Along with that, he has a editor on the several journals. Without spending much time on his introduction, so I request Professor Abbas sir to start his session.
Yes, sir. Hello.
We share your slide from here. That's you can talk on we share
Hello. Hello. Yes, Gunu. So I have connect. I think I am connected, but okay. So I can now use my slide. I can share. Yeah, yeah. I can share now. Okay. Okay. Okay.
Sir, please.
Okay. Let me share. Sorry for the issue. So I guess my slide is visible now to everyone. Is it visible?
Yes, sir.
Okay, okay. So thank you, Dr. Gunwant, for the introduction, and I'm sorry for the disturbance. I think there was some network issue. So today my talk is on structured population models, and so I think the people who are working on differential equation and especially in mathematical modeling, they are very well aware about ordinary differential equation model and then partial differential equation model. So these models, there are certain, one major issue is that they don't consider age as a factor because so they assume that if there is some infection, maybe some disease, then the effect is constant throughout the one's individual's life. But that is not true. So if you want to incorporate such kind of factors, then we need to modify the model. So one such modification or one such model is age structured model, and especially so age is one particular kind of size. So size is more general term, and then one particular model is age. So in this talk, I'll discuss some basics of age structured models and then some tools which are useful to analyze such model. And then if I get time, then maybe I can discuss one concrete model, which is social interaction model. So that depends on the time. So So, as we know that mathematical modeling is an important area of work, research, and in which people try to describe the real world problem using mathematics or in mathematical terms, and then they try to understand the dynamics of certain population or certain disease. So this helps one to predict the disease. So in long and study the current state of the disease, uh, the behavior and events. These kind of predictions are possible. So and then the population dynamics in particular is the study of how the size and structure of the population changes over time, and it has a long history. And these are the some key concepts involved in the structural model. Like we use age structure, which is uh, individual's age, and then we use depends on individual's age. So age plays a very crucial role in these factors. And then fertility rate is also depends on age, and growth dynamics. So the growth dynamics is obviously depends on age of an individual. So, and these are the some areas where such models are applicable. So, understanding age disease transmission. So, in disease also, the severity depends on age, and the rate of infection is also one. So, age is very general term. It can be standard age, which we all know. It can be any other thing. Which so it is a function actually, which is increasing function with respect to time, and satisfies such other positive and other conditions. So, and then in ecology also, it has application, demography, and resource management. So even in fisheries also, the size at age matters. So that is why the better model to represent such the questions in infectious. So we focus more on infectious disease models. So these are the question which on which one who is working on such model is interested, like how the disease spreads and how we can prevent, and what are the main factors, and whether we can apply what kind of on what kind of population. So these can be formulated, and this can be answered partially using how changes within the framework can affect outcomes, and then one can also combine the data to get the better results. And then
Dr. Abbas,
yes.
sorry to interrupt. I think your video is the internet is slightly going out down. So can
Okay.
you switch off your video? We just have
Yeah,
your.
I think then I will get the better bandwidth. So let me just. Okay.
Please go ahead.
Yeah, thank you. So, so these are some advantages of mathematical modeling in epidemiology. So, using models, we can predict these kind of behavior. Now, the idea behind a structured population model is that we need to incorporate one factor, which is age or size in a population. So, if we start thinking about a population, then the starting point must be an individual, and then an individual is like has at least three stages. So first he is born, which is juvenile stage, and then adult, and then at the end the older stage. So we can divide the population in these age classes, and the rates also at which these process occurs, they determine whether the population increases or decreases, or persists, or whether it becomes extinct. So these are some questions. So now to model dynamics, then one requires a link between individual rates and the population process. So uh, this as this is the so if you incorporate the structure population model, so it distinguish individual from one another according to characteristics, which is age, size, location, status, and movement. So these can be considered in an age structured or size structured population models. And the goal is to understand how these characteristics affect the dynamics of these models. So size and age, as I mentioned, they plays a very key role in ecology, and then this model help in predicting the growth and the other factors, and they divides the population into certain age classes, and then the model track the survival and reproduction rates within each cohort to project future population sizes. So the most common is the Leslie matrix model, and then one can go with differential equation model, and then it is partial differential equation model. So in the first most basic model is Leslie matrix model, which actually assume that the population growth is by multiplying the population vector, and then survivorship is the probability that an individual survives from one age class to the next, and then the average number of offspring produced by individual. So these are some factor which is considered in the Leslie matrix model, and the simplest example is nt plus 1 is a times nt, where nt is the population vector at time t and a is the Leslie matrix. So this is one model, and it is the advantage is it's good for species where age plays a key role, and then it's simple and easy to implement. But we are interested in more continuous time model because it's which is more natural because of several factors. So size structure model again divides the population based on sizes, and these are the key components in the model, which is growth rates, and then survivorship and reproduction. So the key approaches in a structured population model is integral projection model, and which actually describe population dynamics through continuous size variables rather than discrete classes, and then a stage-based matrix model, which is one similar to Leslie model, which we have discussed. And then these are the some key factors. So model can be mixed as well, and which is more challenging actually to. So such kind of models are more difficult and more challenging to analyze. Now application are in these areas where one can apply size and age structured model to get the better result and better outcome. So let us discuss basic SIR model where we can incorporate age and then modify our model, and we discuss the key issues. So a basic SIR model divides the population into three components: susceptible, infectious, and recovered class. And then susceptible class is the individual who are susceptible to the disease, infected who are infected, and recovered who have already passed through the disease and they are immune. So the most and these are some important factors in infectious disease model. So the most important factor is basic reproduction number, which gives the idea about disease spread. So the number is a ratio which is denoted by R0, and it represents the number of secondary infections resulting from a single primary infection into an susceptible population. So this is one example, like if one person is infecting how many. So it's so one can see that it in these diseases this is R0 and how it is spreading. So and this data is from this source. No, this is the simple model where if you assume that beta, these are the terms, growth and other factors. So SIR model is given by this, and this is after normalizing. So if N is the population and SIR denotes the susceptible, infected and removed class, if you incorporate these, if you normalize this, then we can write down the model in these three equations. And so one can easily see that if di over dt is greater than 0, then the epidemic occurs because this is the infected class. And this implies that this factor beta st upon alpha is greater than 1. And so then this is related to reproduction ratio. And nearly everyone is susceptible in outset of when at for the, outset an epidemic. So we can say that if S is very close to 1, then we can define R0 as beta upon alpha is the reproduction number in this case. Now, there are certain other important factors, which is one is steady state solutions. So, as we know that computing general solution of an Wilson's equation is highly nonlinear, and it's not easy to compute the solution and to get the solution. So, usually we people are mostly interested in steady state solution and then stability of such solution, that if you perturb this state, then what will happen to the population. So state solutions are actually system of differential equations where the state of the system remains unchanged, and these are also called equilibrium solutions. So if you have differential equation in general dx or dt f of x, so every model can be written in this form in some Rn, maybe R2, R3. It depends on how many classes we are considering, and then the definition of stability is given by this, that if you perturb the initial condition a little bit, then the solution should remain within this epsilon neighborhood of the original solution. So this is again, this gives the idea about the spread under a small perturbation. And the stability can be local and global depending on how the dynamics is. So if it is so these are like if it is true in whole domain, then it is global, otherwise it's so. Now, in population dynamics, the very basic population is the proposed by Malthussian model. It's called Malthussian model because it's a simple exponential model where one can assume that alpha is the growth factor, and so which is given by beta minus mu. Beta is the capita rate of per capita rate of newborn, and mu is the death. So this is the most basic model, and one can easily solve this and to get this solution. But there are several shortcomings of this model, and this model may represent a certain population within a very small time window, but in general it is not a very promising or very good model. So this now this model is again modified, and similarly for another model. So this is single species model. The other most basic model is given by Lotka-Ultra, which is the coupled differential equation model. So this is just if we assume these as if P represent the population and the other factors, then one can. So it just divides the whole population into two classes. One is prey species, one is predator. So population can, I mean, those classes can be prey or predator kind. So it is like applicable in many situations. So it may not be usual prey predator even in like cancer cell. If drug is injected, then drug can act like predator, and then the cell can be prey. So it is a general term. So these are basic single and coupled differential equation models. But these are the issues and limitation. One is unboundedness, so the solution is unbounded, and it can be this issue can be resolved by considering this kind of growth rate, which is proposed by uh, uh, Verhulst, and then it's called the logistic growth model, and this is more natural and more closer to the data under, of course, under a very ideal situation. And if we see the vital rates, if you assume that the rates are constant, then again it's not very natural, because if you, and in this graph, the birth function, which is VA, if one plots, then it is not a constant. It varies with time, and then similarly the mu A also. So as the age increases, the BA first increases and then it decreases, and then mu A is increases as one crosses a certain age. So these factor depends on age. So one cannot ignore these if one wants a model which is more close to reality. And similarly, this data shows that the fertility rate also depends on age, and these are some data on this. So if we incorporate age, then we can divide the class. So mu of A it can be divided into three classes, and where mu CA is age specific mortality rates, and then mu A is adulthood, and then mu 0 is old age. So it is obvious to see that mu 0 is higher than the other two components, right? Because the chances of dying in old age is more, and the infection, even if one has some disease, then the infection may be more severe as age in older age. And this is one data of COVID. So how age plays again a crucial role here. So you can see that it's more severe in older group of population. So, and this data also shows that age-wise there are many disease which is more severe after a certain age. So all this is just to show that age actually plays a very key role in population dynamics, and the very basic model of age is given by McKendrick, and these are the key key elements in the model, that if we denote NTA, so which is the population at time t and age A, and the BA is the birth rate of individual, and then the death rate can be denoted by mu A. So and then NT0 is the class of all zero size individuals, and N0A represent the initial age distribution. Then the basic model, so in OD we have dn over dt, but if n is a function of t and a, then this derivative is actually del n over del t plus del n over del a d over dt. Since age, we assume that it progress with time, so dA over dt is 1. So in this case, this derivative is given by del n over del t plus del n over del a. So we get this model. So this is the most basic model, which is close to single species model, the first model. So where we have del n over del t, del n over del a, and then is equals to minus mu a nta. And then we have to give the term for the zero age individual. So NT0 is given by this integral, and the N0A is some initial population at time 0. and AM is in this case maximum age of an individual in the population. So this model can be analyzed. So this is very basic first order PD model, which can be solved using method of characteristics. So one can get this solution along this characteristic line for a less than t and t minus a0 pi a, and for a greater than equals to t this. And this pi a is the factor which is called the survival function. And this is the probability of the population to survive till age A. And it can be seen that this 0 to AM mu tau d tau is actually infinity, and in this case the pi AM is 0, so which is natural again with. And in order to perform some rigorous analysis, one can consider a more general model with other factors. And such kind of models were considered by Feller, and then Bellman and Cook. They have also considered some general model, and they have given some method to handle such kind of models. So in this case, so we are just discussing the most basic model, and the steady state solution can be found by solving this equation, and which gives this solution that n of 0 is equals to this. And then the basic reproduction ratio in this case is defined as through this integration. And is for maximum population, it is actually 1. And one can also check this that limit t tends to infinity, the population actually satisfies this condition, and lambda is actually unique solution of the characteristic equation. So the result was conjectured by actually Lotka, and then Feller used the method of ultra integral equation and Laplace transform to handle and to solve such kind of models. And then it was again modified, because this model is most basic. It has certain limitations because the fertility and mortality rates just it's assumed that they just depends on age and not on the total populations, and so it's natural to assume that they also depends on total population as well. And the model was modified by Gurtin, and he considered this model, which is more general. And again, using method of characteristic, one can solve this to get this solution. Now one can also incorporate more general class, which is size, and by assuming this that the size increases in the same way for all individual in the population, and is controlled by the growth modulus GS, and which is and then if you consider this integral, then this integral represents the time required for an individual to increase size from S0 to S1. And in this case, the model considered this factor gamma st, and then one forcing term fsst, and this is the one general size structure model, and where these are the terms which we have used. And this model is more difficult to analyze, so one can again compute the steady state solutions and other things. So that's all, and I am not going to discuss the other tools and other model. Thank you so much for the attention. If you have any question, I am happy to answer.
Thank you, sir. Thank you so much.
I have some questions, sir. Sir, I have some questions. Sir,
Yes.
Do you perform some numerical simulations and compare with the realistic data?
Numerical we are doing using MATLAB, but data we haven't done. We haven't used the data yet, but it will be a good work to like use the data and compare the results. And numerical is also not easy. I mean, some people they are working only on numerical aspect of
Yeah,
structure.
because I work in infection disease modeling. That's why because it is not so easy to fit a parameter also.
Yes, yes,
That's
it's
why.
not easy because these are the challenges. Even
Yes, sir. Yes, sir.
getting the accurate age specific data is again is not
It's a
easy.
very big challenge. Yes.
Yes, yes, yes. So the
Okay.
model is, I mean, the general model is very complex. So it even analyzing the model involves several factors. So in PD semi-group theory, one needs for theoretical analysis, and then the other factors.
Okay, sir. Thank you for that.
Thank you, thank you.
Thanks.
Okay.
Any more questions from audience? No. Thank you, sir. Though there are so many hurdles, till you have given your precious time, valuable time to come and interact with us. So on behalf of the department and ICT, we are very much thankful to you. Thank you so much.
Thank you. Thank you all for attending. Bye.
Thank you so much, Ravat sir, for your wonderful talk. I thank Dr. Ravat sir from ICT Mumbai for chairing this session. Now I request everyone to move ahead for tea break and please come back in 5 minutes. We are already running behind the session. So the next session will be chaired by Dr. Devashita ma'am, and the parallel session is have started in A135. So please come back in 5 minutes.
So those who have session, please grab your tea, come quickly and get everything set. Please be on time. Please respect the time. That time will also respect us.
कौन है इसके बाद वॉलंटियर तब तक नाम पूछ सकते हो तुम लिस्ट में देख के नाम सीरियली भी रेडी होने के लिए
Also, the certificates for the sessions are ready. You can collect it from the registration desk before going to. For the session 2D, Shyam Das, Patil PS, Dubey SA, and Abdullah Diksha, please be ready and on time.
अजय किधर अजय अजय
लोगों को देखा है, इसके पति
Can you hear me? Hello, everyone. Hello, can you hear me?
Yes, we are on a tea break. We'll start in 5 minutes.
ये ऐसा क्यों हो गया रे?
Presenting my contributed of A, sir. Hello.
Hello.
Are you presenting a contributed of?
Yes. I have presentation now. Myself, yes, myself, Dr. Shamsuman Das. I will present now.
Can you please change your name?
What I cannot understand. What are you telling?
Asking you to change your name. You have written A, sir.
I have already shared the slides. If you permit me, then I can share my slides also.
You could share your slide.
He's asking you to rename your Zoom ID, which is named as Acer, no? So if you could put in your name.
I have to put my name.
Zoom ID.
And it is preferable if you present your PPT by yourself. So since you are online, okay.
Okay. So what I have to do? Because Ame sir sent a Zoom link in the morning today, right? Right.
Yes, sir. You can.
Sir, is he audible to you now?
Yes, it is audible now. Before it was not.
Sir, you have named yourself as Acer, so I'm just asking you to change your name, and and you should present your screen on Zoom. Since you are presenting on Zoom, it is preferable that you present your.
Yeah. But I need to know how to do by change my name myself. Wait.
Yeah, just rename your Zoom ID.
Okay. You can rename my Zoom ID. Sign in. Wait.
Second.
So Shailesh, sign in. Then I will do.
I'll rename you.
We'll do it. We are the host now, so we can do it.
Okay. Just do it. Shyam. S-H-I-M. Shyam.
SHIM.
S-H-Y-M.
I have changed your name, sir.
Yes. Thank you very much. We'll just wait for the audience, then we'll start in 5 to 10 minutes. I don't know.
Yes, sir.
So you are doing master's degree there at ICT?
I am in a master's degree.
I did my PhD. I am the first PhD student of Department of Mathematics, ICT Mumbai.
अच्छा, you are a senior.
मैं साउथ सर का स्टूडेंट था. 2012 में PhD किया था मैंने.
Okay.
So it's like coming back to my home. I stayed 6 years in ICT Mumbai. In hostel 5. मैं hostel 5 में रहता था. मुन्ना कैंटीन और गोदरेज कैंटीन में हमारा टाइम चलता था उधर ही. क्लासिक जाते थे हम लोग.
Yes, sir.
So you are from Mumbai?
Senior. I'm in a second year. She's in a first year now.
Hello, sir. I am Hiloni
I
from
am your super. I am super senior. I am the first PhD student. I am the first student in Department of Mathematics. In 2000, I joined in 2007 and 2012. 5 years.
2007, no?
Yes, I was at that time. Ajit sir was there and Sahu sir was there. Nobody else was there.
With
Sahu sir.
Sahu sir, oh.
I was the first PhD student of Sahu sir. Second was that I forgot his name. Forget his name. He is a faculty in ICT branch in
Jalna.
Maharashtra. Yes. Her name is forget his
Jalna.
name. Yes.
Senior है.
Super senior.
2007 batch. Super senior. 2007 batch के PhD student.
2012 में मेरा PhD हुआ था. उसके बाद मैं बाहर चला गया था. पोर्तुगल में था, ब्राजील में था. अभी मैं ब्राजील से आया. अभी मैं इंडिया में हूँ. Nice to meet you guys. Think like मैं आपका सब Instagram पेज देख रहा था. मुझे बहुत अच्छा लगा देख के कि अपना डिपार्टमेंट कैसे ग्रो कर रहा है.
All that credit goes to Gopal sir. उसने बनाया Instagram पे reels and everything.
सही. LinkedIn वगैरह में पोस्ट करते रहो सारे इवेंट्स वगैरह.
Yes, Homik sir, he posts everything on LinkedIn.
I have contact with Momik sir. Yes, I have contacted Ajit sir and Momik sir. I know them personally.
Yes, sir.
I actually missed the opportunity to visit ICT because I am busy in my work here, so I didn't get much time to visit. So otherwise, I will visit the conference.
Yes, sir. We'll start in some time.
Okay. It's already 48 minutes late.
फर्स्ट ईयर में बोलती तो अभी उसका ट्रांसफॉर्मेशन
Thank you, Miloni. So for this session, we would like to have first Sham is that. So he will be joining us online and yeah, he is already.
So shall we start the session or we wait some other guest? Like Ajit sir is not. I cannot see Ajit sir and Momik sir. Others are.
Here only, please start. You can start.
See Momik sir.
Yes, I can see Momik sir is sitting there. Yes, sir. Okay, sir. Shall I start?
Yes.
Okay. So I will share my screen. So please permit me to share my screen. So can I share my screen?
Yes.
Okay. Okay. Just give me some minutes. So just give me just. So we'll start now. Okay. So good afternoon, everyone. So myself, Dr. Samsuman Das, and I feel really good to back to my home because I'm the first PhD student of ICT Mumbai. I did my PhD under Dr. A.K. Sahu. So I was there from 2007 to 2012. So it's almost 13 years I left ICT, and I have lots and lots of memory. So at that time the department was very small with Ajit sir and Sahu sir, and there was a I'm very much happy to see how the department is doing and growing, and with like faculties, and there are many faculties and there. So it's really very good to see all of you, and I'm very sad that I cannot come physically to to my institute where I visit my places and all these things. Anyway, so I will start with our work. So this is a collaboration work with Professor Claudia Diaz. So she is my supervisor when I was in Brazil. So right now I am an associate professor in Department of Mathematics at School of Basic Sciences, Chandigarh University, Lucknow, Uttar Pradesh campus. I joined actually last year. Before that, I was after my PhD, I moved to Portugal for a one postdoc. Then I was in almost 10 years. I did four, like almost total I did 11 years of postdoctoral research experience. Then I came back to India last year. So I will start. So with Claudia, actually I did this work. So the title is Optimal Control Strategy for Multi-Strain Dengue Dynamics in Rio de Janeiro. And multi-strain means we are going with two strains only. So it is a two-strain approach. So okay, sorry. It is not. Yes. So the outline of the presentation, I will start with some introduction on the global incidence of dengue by 2024. Dengue incidence in Brazil, why multi-strain dynamics for dengue disease is important. Then the mathematical model that we propose, then some optimal control formulation. Then we'll show some optimal control solutions and summary of the work, then future work and some references. Okay. So global incidence of dengue. So as you know that dengue, dengue is a lethal disease and it is a vector-borne disease. And you can see this map, almost all the tropical and subtropical countries, dengue is become endemic. So worldwide, see 90 million people are getting infected, and it is endemic in 20 countries. So it is a big number. So, and also the number of dengue cases worldwide is increasing because of the increase in global temperature because of this climate change. So it's very much important to understand how this infection spread because of the four strains circulating, like almost like this. As you see in the, because this image is so small, but you can see if you want, just wait. I have the much bigger picture. Can you see the screen? Can you see this one?
It is freeze. We
Let
cannot
me.
see its moving.
Okay, wait. I will share it again. Just wait. I will share my entire screen. So, shall enter general the screen. Yes. So can you see now? Can I? Yes. So this is a global incidence map from WHO. It shows that all the tropical and subtropical countries, especially all the Latin American countries and in Mexico and some part of Africa, India, because India is showing the white because there is no data is obtained. It's very strange why data is not obtained. And some part of Australia, then Indonesia. You see, almost all the major countries, they are all going through this dengue epidemic. So dengue is a global problem now. So okay, so I will go to the slide. Where is the slide? Okay, yeah, the slide. Yes, yes. This multi-strain, basically what is happening, like one you infected one dengue strain, you'll get some immunity to the strain one. Like it's you'll get some partially or temporary immunity, but after that what is happening, because of the other, when we will be exposed to other strain, like when the secondary infection will happen, then there is a then your body will produce some antibodies. These antibodies will form some complex with other strains. It become a anti-dependent enhancement mechanism. So this is a more lethal. This will cause to dengue, like severity of dengue, like dengue shock syndromes. It in more severe cases, the people will die, the children will die. So it is very important to study multi-strain dynamics. Let us move to Brazil. Why I select Brazil? Because I was in Brazil for many years. And also like dengue is really endemic there. So in Brazil, sorry. Yes. So one of the highest dengue burdens in the world, all the serotypes were present in circulated in Brazil. Seasonal epidemics with risks of reinfection and severe cases, climate urbanization, and human mobility intensive transmissions. So you can see this map. I have the map here. I can also see the map. Yes, this map. Yes, you can see almost all part of the Brazil. What happened? Yes, almost all the part of Brazil. Completely exposed to this dengue virus, or like all the serotypes are circulating around the different parts of the Brazil, especially last year in 2023 or 24, because of the effect of El Nino, dengue cases just shoot up there. I was there, a lot of people got infected, some people also died. So that's why multi-strain dynamics is really important.
Sorry for the interaction. The almost 8 minutes is over. So
Okay, I just yes. Why model of multi-strain dynamics is important? Understand spread of strain interactions, how different strains are interacting with each other, and how it is affecting the population size. Analyze the temporal cross immunity, prediction, reinfection, and severe cases. And also in this study, we'll use optimal control approach. Like we have taken 3 control variables. One is the degree of awareness between the human population. Another is the vaccination rate. Another one is that vector control. We interest like in the coming slides, so I will explain it. So this is the model. Okay, so this model basically this is a vector-borne model where so this is the first part, which is the human population, where the here S is the susceptible population, I1 and I2 are the infected population with strain 1 and strain 2. R1 and R2 is the recovered population from strain 1 and strain 2, and I21 and I22 is the secondary infection because of the like when you will infected to strain 1, then you'll get immunity to strain 1, but you will susceptible to strain 2. So that's why you can see here. So there is the R1 and the beta V2 and IV2 term is there, and DRY/dt is the recovered rate. So and here if you see in this first equation, this AWT and UBT, these are the control variables. Like AWT is the degree of awareness and UBT is the vaccination rate. Similarly, if you go to the vector equation, So here you can see we see like the first part here is the in like IB1 and IB2 is the infected mosquitoes due to strain 1 and strain 2, and here you can see the vector control population VC. Okay, so this is the optimal control problem. To obtain the optimal control, optimal control solution, we need to define the first what is the cost function here. Okay, we objective to minimize the cost functional. We aim to minimize the total number of infection and the cost of the applying control measures over the time period 0 to t. Okay, and this is J is the integral of this function. This function is a function of I1, I2, AW, VC, and UV. And objective is to obtain the minima for this integral. So next, we'll define the Hamiltonian for the general form. So H is equals to G of XU plus adjoint term, where G of XU is the integrand of the cost functional given by this expression, and this is the quadratic term. So adjoint. Hello.
We are short of time. Actually, you are wind up please in 1 minute. 10 minutes is over.
Yeah. My time is over.
Yes.
Please give me 5 minutes. Just I will finish it just quickly. So adjoint term represents the weighted sum of the state equations, and here the existence of optimal control solution. We obtain the existence of optimal control using the quantization condition. So this is the this set basically is convex and closed. Dynamics are ellipses in X, measurable in T, and cost integrand is convex in U. And this is the Hamiltonian, the adjoint equation in. So the optimal control solution, like the optimal control solution exists when this adjoint equation of the solution. So here I will show you next. So this is the adjoint system with the turbulent condition lambda I t is equals to 0. And when you will obtain like the Hamiltonian equals to Hamiltonian the partial derivative of H equals to AW equals to 0. So this is the optimal control solution, and solving this this equation you will obtain the optimal control variables here. So this is the optimal control variable, and the summary developed two state with temporary cross humidity added these three control strategies, derive the necessary condition for using quantization principle. The future work will obtain the numerical optimal control solutions, like we'll test the different effect of different values of control variables, how it is affecting the overall infection dynamics. So references. So thank you everyone for your time, and if you have any questions, please let me know. Thank you.
Thank you for the presentation. And I think, do we have any question? We can take just one quick question. Yeah, I think the question is not there. So if somebody else have question, they can contact you through the email IDs. Okay, and thank you once again. So now we will move to the next speaker. SP Patil. 10 minutes.
Thank you for.
Good evening, everyone. Thank you for giving me this opportunity to present my work in this conference. I am very grateful to present this work in front of ICT members and students. So, my title of the paper is Extension of Euler's Theorem on Homogeneous Function using Katu-Gampola Fractional Derivative. So, the basic abstract is we wanted to use the fractional derivative instead of using the regular fractional derivatives which do not follow the regular properties, the classical properties of differentiation. So the main part is the Katu-Gampola fractional derivative for bivariate function. Then the basic properties relation between Katu-Gampola fractional derivative and the ordinary derivative. When we generalize the Euler's theorem for fractional derivative in terms of Katu-Gampola derivative form, and generalize that Euler's theorem for composite functions as well. So Katu-Gampola introduced a unified fractional derivative that bridges the Riemann-Leibniz and Caputo form while preserving the key mathematical structures like chain rule, composite function, fractional derivative, as well as the product rule. So application of this fractional derivative can be useful in control systems, signal processing, and machine learning, where the fractional operator improves modeling, its stability, and it can be used in feature extraction for multiple parameter family of curves. So Euler's theorem on homogeneous function, it is the cornerstone. It is extended by Dr. Hibreker. So instead of taking second order partial derivative, we can generalize it to order n, and we use the same context in terms of fractional differentiation. So this paper deals with the development of Katu-Gampola fractional derivative for bivariate functions. It establishes the fundamental properties, generalized Euler's theorem on homogeneous bivariate function, and provides illustrative examples to support the theoretical results. So the main definition, this is the work, the limiting definition of fractional derivative of order alpha, where alpha will lie in between 0 to 1. So we can differentiate it of order alpha with respect to variable x as well as with respect to variable y. So this is the basic properties of the fractional derivative. We can prove linearity, product rule, quotient rule, chain rule in terms of fractional derivative. And this is the most important theorem which generalizes and defines the relation between fractional derivative of order alpha and ordinary fractional derivative. So here we have used the simple generalized proof. So Euler's theorem on homogeneous function of order alpha, of order 1 alpha, can be derived in this way. We can generalize it to 2 alpha, 3 alpha, and so on. And this is the generalized Euler's theorem. If h0 is your homogeneous function in two variables, and f is alpha differentiable function for any alpha lying in between 0 to 1, we can derive this result by using the basic mathematical induction. The same thing can be done with respect to composite function. If we have composite function GOF, then we can differentiate it with respect to variables x and y of order alpha. Again, the derivation can be done by using mathematical induction, where we can use the previous theorems. So if we consider the identity map for composite function, so theorem 4.4 will give theorem 4.5. So for alpha is equal to 1, it can generalize the results derived by Dr. Hibreker. So the known theory of Euler's theorem has been applied in this paper to find the alpha fractional derivative for the function. So these are some examples. If your function is continuous and differentiable, so we can apply those theorems to find out their derivatives. So this paper presents new insight on Katu-Gampola fractional derivative for bivariate function, further extensions of Euler's theorem on homogeneous function. There is scope to develop results and its generalization in practical implementations, particularly in AI and ML. Whenever we have multiple parameter family of equations, we can use it for feature extractions as well as improving the stability. So that's it. Thank you again.
Thank you for the nice presentation. Okay, so now we will move to the next speaker. Asia Thube. I think Supriya Thube, she is online.
Yes,
You can
ma'am.
share your screen.
Yes, ma'am.
Yeah, it is visible.
Okay. Am I audible clearly, ma'am?
Yes, yes. So you have 10 minutes.
Okay. Can I start?
Yes, you can start.
Okay. Good afternoon, respected dignitaries present over there. I'm Supriya Ashish Dubey from Vidya Pratishthan's Kamal Nayan Bajaj Institute of Engineering and Technology. Today I'm represent my paper on new result on degenerate trigonometric functions and their properties. Here I discuss abstract, introduction, preliminaries, main result, conclusion, and references. Abstract is trigonometric function plays an important role in science, engineering, and technology. Generalization of trigonometric function has important role in development in modern science and applied mathematics. This paper deals with degenerate trigonometric functions and their properties, starting with basic definition. We obtain new trigonometric identities of degenerate trigonometric functions. Also, we obtain some result on derivative and integrations. Introduction. In 1993, F.Q. Gava published book on p-adic number. The p-adic number, where p is any prime number, which give an alternate way of finding the distance between two rational numbers. It has many applications in number theory, analysis, and algebra. In 2011, R.C., Radel, and CO obtained the formamic p-adic Q-integral representation on ZP. Kim Hai-Kong introduced degenerate trigonometric function arising from p-adic integral on ZP. Kim T, Kim DS, and Kim HK works on degenerate hyperbolic function arising from p-adic number. Kim Das obtained some identities on degenerate trigonometric functions in 2024. Here we required some preliminaries. Here we refer degenerate trigonometric functions arising from p-adic integrals on ZP by Hai-King Kim in 2023. Let ZP, QP, and CP are the rings of p-adic rational integers. The field p-adic number are the completion of the algebraic closure of QP, respectively, with p is an odd prime number. Here I given p-adic integrals definition, and definition is integration over Zp f of x d mu of x is equal to limit running over n to infinity summation from x equal to 0 to p raised to n minus 1 f of x mu of x plus p raised to n Zp is equal to limit n tends to infinity 1 upon p raised to n summation f of x running over 0 to p raised to n minus 1. Say as equation 1. From this equation, we have the result integration over Zp f of x plus 1 d mu of x minus integration over Zp f of x d mu of x equal to f dash of 0, where f of x is uniformly differentiable function on Zp. A study on the harmonic p-adic integral, the RC and irradial D and COJJ represent the definition of harmonic p-adic integral on Zp, and the definition like that integration over Zp f of x d mu minus 1 x is equal to limit from n to infinity summation running over 0 to p raised to n minus 1 f of x mu minus 1 x plus p raised to n Zp is equal to limit running over n to infinity 1 upon p raised to n summation minus 1 raised to x f of x running over 0 to p raised to n minus 1. From that equation 3, we have the result integration over Zp f of x plus 1 d mu minus 1 x plus integration over Zp f of x d minus mu minus 1 of x is equal to 2 f of 0. Here we refer the paper on harmonic p-adic integral. Here some notation and definitions are given. For lambda in R, the degenerate exponentials are defined by e raised to x lambda of t is equal to summation of x and lambda t raised to n upon n factorial and running over 0 to infinity and n strictly greater or equal to 0, where x 0 comma lambda is 1, x n lambda is x, x minus lambda, x minus 2 lambda, and so on, x minus n minus 1 lambda for n greater or equal to 1. Here, if we take limit tends to 0, lambda tends to 0, e raised to x lambda t is equal to e raised to xt. That is usual exponential function. And if we say e lambda of t, that is nothing but e raised to 1 lambda of t. Here we have following degenerate functions. By using the exponential function, we define that new trigonometric degenerate functions cos lambda x of a is equal to e raised to xi lambda of a plus e raised to minus xi lambda of a by 2. Sin lambda x of a is equal to e raised to xi lambda of a minus e raised to minus xi lambda of a by 2i. By using sine and cosine function, we can define tan and cot function also. If we here is most important remark, if we get usual result of trigonometric functions with a is 1 and lambda tends to 0. For example, if I take limit lambda tends to 0 cos lambda x of 1, I get value as a cos x. Here are some new results. The degenerate trigonometric sine function is odd function as usual. Cosine function is even function. Some lemmas are given here. Sin lambda 3x of a is equal to 3 times sin lambda x of a minus 4 times sin cube lambda x of a. Lemma 2 is cos lambda 3x of a is equal to 4 times cos cube lambda x of a minus 3 times cos lambda x of a. Tan lambda 2x of a is equal to 2 times tan lambda x of a divided by 1 minus tan square lambda x of a. Some result on product to some identities for new degenerate trigonometric result. If we take product of sine and cosine function on degenerate trigonometric functions, we get the result as sin lambda x of a into cos lambda y of a is equal to 1 by 2 times sin lambda x plus y of a plus sin lambda x minus y of a. Same way we can define sin lambda x of a sin lambda y of a is equal to 1 half cos lambda x minus a x minus y of a minus cos lambda x plus y of a. Cos lambda x of a cos lambda y of a is equal to 1 by 2 times cos lambda x plus y of a plus cos lambda x minus y of a. Here are some half angle identities that are given. One identity is for a in R, we have sin lambda x by 2 of a, we can define as plus minus under root of 1 minus cos lambda x of a by 2. Similarly, we can define for cos lambda and tan lambda also. Here are some derivatives of degenerate trigonometric functions. So, derivative of e raised to xi lambda of a with respect to x is I upon lambda log of 1 plus lambda a e raised to xi lambda of a. Derivative of e raised to minus xi lambda of a with respect to x is minus I by lambda log of 1 plus lambda a e raised to minus xi lambda of a. By using these two results, we can define the derivative of cos and sine function as derivative of cos lambda x of a is minus 1 upon lambda log of 1 plus lambda a sine lambda x of a. And for the sine function, derivative of sine lambda x of a with respect to x is 1 by lambda log of 1 plus lambda a cos lambda x of a. Here are some new theorems. For a in R, mod lambda a less equal to 1, derivative of sine lambda x of a we can represent in new way cos lambda x of a by cos lambda x of a divided by lambda into summation run over 1 to infinity minus 1 raised to n plus 1 lambda a raised to n by n. And for the cos function, if I take derivative of cos lambda x of a with respect to x, that is equal to sin lambda x of a by lambda summation n running over 1 to infinity minus 1 raised to n lambda a raised to n by n. Here we can define derivative of x plus y function If we take derivative of cos lambda of x plus y of a, we got result as sin lambda x plus y of a by lambda summation minus 1 raised to n lambda a raised to n by n and running over 1 to infinity. Again, derivative of sin lambda x plus y of a with respect to x is cos lambda x plus y of a by lambda summation minus 1 raised to n plus 1 lambda a raised to n by n. Here we get some integration results. For lambda non-zero in CP, A belongs to 1 by lambda in U. Here U is defining U is additive set. That U set is X in CP mod of X is less equal to P raised to minus 1 upon P minus 1.
2 more minutes. Please wind up. Your time is up.
Yes, ma'am. Yes, ma'am. Integration over ZP cos lambda x of A d mu of x is equal to minus 1 upon 2 lambda log of 1 plus lambda A cot lambda 1 half of A. So this integration is about p-adic function, that d mu of x is correspond for the p-adic function, and corresponding integration of sin lambda x of A d mu of x is minus 1 upon 2 lambda log of 1 plus lambda A. Here is some new theorems. Integration over ZP cos lambda x plus y of A d mu of x is minus 1 log 1 plus lambda A upon 2 lambda sin lambda 1 half of A into cos lambda y plus 1 half of A. And same for the sine function here. For the harmonic p-adic function, we have the result integration over Zp cos lambda x plus y of A d mu minus 1 of x is cos lambda y minus 1 half of A divided by cos lambda 1 half of A. And same for the sine integration over Zp sin lambda x plus y of A d mu minus 1 of x is sin lambda y minus 1 half of A divided by cos lambda 1 half of A. And for two examples are given to you. I take integration of same function with respect to p-adic and harmonic p-adic function. Here is p-adic function. For that, if I take integration of cos lambda x plus 1 of A with respect to p-adic function, I got result minus 1 log 1 plus lambda A upon 2 lambda sin lambda 1 half of A into cos lambda 3 by 2 of A. And if I take integration with respect to harmonic integral, I get result as a 1. So conclusion, we introduce new result on degenerate trigonometric functions, which includes basic properties of trigonometric functions, even odd functions, product of two degenerate trigonometric functions, half angle formulae. We are able to derive derivative and integration. For these functions, there is a future scope to develop theory and its corresponding application. Okay. Anyone? Anyone question?
Thank you, Shukriya. So we can take one quick question.
Thank you.
Okay. So I think I have one question, Shukriya. Can you just tell us one application of this trigonometric function?
Degenerate trigonometric function, we can use it in algebra, geometry. We can use
specific application.
Yes, ma'am.
Some specific application if you have come across. So yeah, I think then you can explore this one, okay, and which might help you to inspire the young students also, because nowadays we have seen that students want to know always the application of any theorems whichever we are saying. Okay, thank you once again. So now we will move to the next speaker. Diksha P. It's a 10 minutes. Okay. So good evening everyone. Myself Diksha Tukri, and I'm going to present my work title Properties of a Generalized Double Laplace Transform and Special Functions at the National Conference on Computational Geometry Analysis and Machine Learning. This work focuses on the generalized double Laplace transform and its key properties. So this presentation is based on the following key points. So integral transform, particularly the Laplace transform and its extension, plays vital role in various scientific domains. And this paper deals with the new results on the double generalized Laplace transform and special function. Starting with the basic definitions and results, we have obtained the generalized double Laplace transform to unit step function and develop new theorems, and finally illustrate our results with the examples. So, Laplace transform introduced by P.S. Laplace led to various integral transforms such as the Fourier transform, Above transform, Kumar transform, etc. Extension like double Laplace transform, double Alzheimer transform, modified double Laplace transform have been developed and with the main potential for further generalization. So, this works extend the generalized double Laplace transform of this work extends the generalized Laplace transform to generalized double Laplace transform, aim to solving multi-dimensional partial differential equations. So here are some preliminary results that we are using in our paper. First is Laplace transform defined by Deepnath and Bhatta. Second is generalized Laplace transform defined by Farah and Rahman. Third is double Laplace transform defined by Deepnath. And this is the definition. Hibrika sir and I have defined this generalized double Laplace transform by this definition. And here is the definition of a Heaviside unit step function that we are using in our paper. So, okay. In previous paper, Hibrika sir and I have obtained a new relationship between the classical double Laplace transform and the generalized double Laplace transform by the following theorem. Also, we have obtained a sufficient condition for the existence of a generalized double Laplace transform with the properties like linearity, shifting property, scaling property, then change of scale property, convolution theorem, etc. with the examples. This corollary we are using. So coming to the main results, we have developed some additional results on the generalized double Laplace transform. Okay, so for this work, we developed some additional, in this work, we developed some additional results on the generalized double Laplace transform, which are provided as a part of a continuation in my previous paper. So we consider f of x comma y to be exponentially ordered and piecewise continuous function with psi of 0 is 0 and psi of 0 is 0, and such that the generalized double Laplace transform exists. So these are the theorems that we have obtained. Next, the proof by using the usual definition that we have obtained. And here are the theorems based on a Heaviside unit step function. So first is generalized double Laplace transform of h of x minus alpha comma y minus beta is nothing but 1 upon p cube e raised to minus of p psi of x plus q psi of beta. And where h of x comma is defined by the equation 2.5. And here is the proof. Here are more theorems. Okay, so by putting psi of x equals to x and psi of y equals to y in our original or this obtained results, or we can get the results by Deepnath as a special cases of our results. Here are some illustrative examples. So, okay. So in conclusion, this paper presents the new results on the generalized double Laplace transform and formulas for unit step functions using generalized double Laplace transform. New theorems and proofs and examples were provided to support the theorems. In future, we'll explore the new properties and theorems related to the generalized double Laplace transform to deepen the understanding of the application. We also investigate the use of the generalized double Laplace transform in solving complex differential equations. Additionally, we will compare the generalized double Laplace transform with the other well-known transform like Fourier transform to highlight its advantage, limitations, and potential areas for improvement. Lastly, I would like to express my sincere gratitude to the organizers of National Conference on Computational Geometry Analysis and Machine Learning for providing a valuable platform to present my paper. And these are references that we are using in our paper. That's it from my side. Thank you. Thank you, Diksha. So, any question?
I just wanted to see what conditions on psi and
Psi and Xi. Psi and Xi.
What conditions on psi and Xi are there?
Psi and Xi. This is the basic definition. Psi and Xi both are non-negative increasing continuous functions. With psi of 0 is 0, psi of 0 is 0.
So any function which satisfies this property, you can define.
Yes, yes, yes.
So do you think like when you are going to suppose you apply to some partial differential equation, how did you choose this psi and Xi? Do you have any idea?
Any function, you can take any function. Like if your function satisfies this condition, for that
you can. What I'm saying is, suppose you want to solve a differential equation, then do you think the psi and Xi should depend on the differential equation where you want to apply? You follow my question because you said that
it will depend on initial condition, boundary
because
condition.
you have to compare with that
Yes.
guys that x psi equal to x and that.
Yes, yes. Okay, so I once again thank all the speakers for presenting their papers. Now I'd like to call the learning.
Thank you so much, everyone, for such insightful talks. Thank you, Dr. Mukherjee, for facilitating this session so smoothly. I would like to call Dr. Ajit Kumar to felicitate Dr. Devaswata.
Thank you very much.
I would now like to request everyone to proceed towards Marble Hall for the poster presentations, and please return back at 5 o'clock, by 5 o'clock, so we can have the validation session. Alumni